All right, so hello, and welcome everybody in the class. Hello, everybody. Hello, Bhavani. Hello, Vexo Pulse. Hello, Jayashri. Hello, everybody. So, first of all, tell me if I'm clearly audible and visible. Hello, everybody. How are you? So, my dear kids, today we'll be discussing a concept called as motion in a plane. Hello, everybody. Okay. So, we will be starting right away with today's class, right? And we'll be discussing a lot of interesting ideas in this session, right? Okay. All right. Hello, everybody. Right. So, if I'm clearly audible and visible, just give me a quick yes, and we can start right away with today's session, right? Motion in a plane. This is the topic of today's class. A lot of interesting things that we have to understand, and primarily we have to talk about the projectile motion in this particular session, right? For circular motion, right, when we talk about motion in a plane, there are two parts: projectile motion and circular motion. Both of them can be a good example of motion in a plane. But for circular motion, we have another lecture, so we'll be discussing all that over there, right? Hello, everyone. All right. So, my dear kids, I am Gaurav Tiwari, and today we'll be learning the concepts of motion in a plane. And as I said, these are the topics that we will be discussing. So, I have divided this lecture into two small parts, right? So, because we have to cover everything in this lecture, so this is the first set of concepts. My dear kids, in the previous chapter, when I was teaching you the concept of motion in a straight line, we have already discussed position and displacement, velocity in velocity in one dimension, right? We have talked about position of a particle, displacement of a particle, velocity of a particle, acceleration of a particle. Those are called as terms of motion, right? Today we'll be discussing those terms of motion, but in two dimension, right? So the velocity in two dimension we will talk about, position and displacement we'll talk about in two dimension, right? And after that, we'll be talking about acceleration in two dimensions and then some basics of projectile motion. So this is a very important part, right? And that will enable us to talk about the advanced concept that we are going to talk about in projectile motion, right? So hello everybody, right? So I can see your chats directly in front of me, and if there is anything, any question, any problem, you can definitely ask me in the chat box, right? Okay, so let's start. So after these five concepts, all the projectile motion questions, topics are written over here. So we will start from projectile motion is a combination of two different types of motion, right? So this is where we are going to understand the concept of breaking the motion. I say that breaking the motion just to understand the projectile motion in a better way. Then we will talk about the understanding the roles of each component, right? And basically this is in combination with this one, right? And after that, we will talk about time of flight, and then maximum height and range, right? These are very, very important ideas, okay? And equation of trajectory, after that we will be discussing. This derivation of that is also very meaningful. Projection from the elevation, speed of impact, and range or from the foot of an elevation. So these are all the topics that we'll be discussing today one by one, right? And circular motion, as I said, is not a part of this class, right? So we'll be discussing only this much in this section, session, right? Yeah. All right. Ranjan, focus. Rajan. All right. So let's start right away with this class, right? Position and displacement. This is the first thing we have to talk about, my dear kids. So let's focus. What is this diagram? What do you mean by this diagram? Let's talk about that. So over here, you see that so far all the objects were moving in one dimension, right? One dimension. So either the objects were moving like this, their x coordinate is changing with time, or the particles are moving like this, their y coordinates is changing with time, right? Since it is a motion in two dimension, my dear kids, so now their two coordinates will change as the name suggests. Right now the particle could be here at point P, right? And after the time T, delta T, the particle can move to another point, point Q, right? So how will you write this particular vector? In the previous sessions, we have understood there is a thing called position vector, right? In the space, if there is a coordinate of a point x1, y1, then the position vector of that particular point is this vector. This vector tells us about the entire idea with respect to a certain reference point O, what is the location of that point? For example, OP vector is the position vector over here for the point P. It is going to be x1 I cap and y1 j cap. Yes or no? Right. And similarly, I can join this particular point Q, right? Object is moving from point P to point Q. Point P has a position vector xi plus y1j, and point Q is x2 y2. So clearly, this one has position vector x2 I cap and y2 j cap. Yes or no? Right. This is going to be the position vector of this point OQ vector. I believe the idea is very, very clear, right? So now you see that, yes, now you see that what is really happening. The displacement vector, when I talk about the displacement vector will be represented by this sign, this particular arrow, right? So you see that basically you are moving from P to Q, right? You are moving from P to Q. This is the displacement you are carrying. This is the displacement you are traveling. OP vector, or you can call it R1 vector. OQ vector, or you can call it R2 vector, like this. This is R1 vector and this is R2 vector, right? Position vector of point 1 and position vector of point 2. So what will be the displacement vector between them? So we can say that if you are moving from point P to point Q, you already know the position vectors of point P as well as point Q. So the displacement vector will be delta R. This delta R vector, you can say, is going to be R2 minus R1, right? So just put the value of R2 and R1 and subtract it. X2 minus X1 I cap plus Y2 minus Y1 J cap. So this is exactly what is written over here, right? So you are moving from initial place to final place. So you see that position vector of the final place minus position vector of the initial place is the displacement vector, I hope the idea is very, very clear, right? So this is very, very important when you try to write down the displacement in 2 dimension, right? Because when you are going to move right now, you will change the x coordinate as well as the y coordinate. So the correct definition of displacement can only be written, the correct expression of displacement can only be written when you can successfully write the displacement vector, right? So here I have written already that R1 vector is this x1 plus I plus y1j, R2 vector is this x2y plus y2j. So displacement vector will be R2 minus R1, which is this x2 minus x1 I cap plus y2 minus y1 j cap. They just subtract it. So I believe the idea is very, very clear. Let's solve a basic question on it, right? So this is a question and you have to answer me in the chat box, right? Quickly answer it, right? Quickly answer it, right? Hello Manju beta, right? Quickly answer it. So here we have the first point R1, 2y plus 3j. Second point is 5y minus 2j. Find the displacement between R1 and R2. Find the displacement between R1 and R2, right? Displacement vector, basically you have to talk about. These are the two options. What will be the displacement vector, right? What will be the displacement vector? Answer it in the chat box. Option A or option B? Answer it in the chat box, my dear kids. Answer A, option A or option B? Quickly answer it. What will be the displacement vector? Right, I'm reading your chats. Quickly answer it, right? What will be the displacement vector? So here we can say that the displacement vector here, my dear kids, will be, right, R2 minus R1, right? This is the displacement vector, okay? So just put the value of R2, 5i minus 2j, 5i minus 2j minus this thing. So minus 2i minus 3j. So just add it up. So it is 3i minus 5j. Alright, so which is option A? So option A is the correct option. So let's move on and talk about the next question, right? So this question you can try, okay, and try to solve it. A person moves 30 meter north, 20 meter east, 30 root 2 southwest. Find the displacement of the person from the original position. So here again, the person is not only moving towards east or towards west or only towards north, towards south. It is not moving in one dimension. It is covering more than one dimension. So here it is covering 2 dimension. First of all, he is moving in north. So you know that this is east, this is west, this is north, this is south. So he is first moving 30 meters north. Then he is covering 20 meter east like this, right? 30 meter north, 20 meter east, and finally 30 root 2 meters southwest. So this is south, this is west. 30 root 2 meters southwest. Let's say that this is the 30 root 2 southwest, right? Okay. So we have to talk about the displacement of the person from his original position. Think about it, right? Just think about it for a minute and try to solve it on your own, right? When you try to, yes, think about it. Very good. What is this, kid? Dark aura. Dark aura. Where is the doubt, beta? Okay. How is not a doubt? Actually, there is a lag, right? So your question and my explanation are slightly different. So the chat you do is generally 5, 10, 20 seconds delayed than the things I am talking, right? So what you can do is you can write down your entire question so that I can answer it. Okay. Right. So let's try to answer it, my dear kids. So here it is very, very clear. As a question suggests that first of all, how you are moving? You are moving first of all in this direction. So you see that, let's say the unit vector in this direction is I cap, in the upward direction it is j cap, and in the z direction it is k cap, but that does not matter right now. So here it is, right? So what is the unit vector in the southwest direction, by the way, right? Let's say the displacement is 30 root 2. So what will be the unit vector in the southwest direction? First of all, you need to know the unit vector in the southwest direction, right? So because you know that, in the vector class you have already understood that if a vector A needs to be written, then the magnitude of vector A, if it is multiplied by the unit vector in the same direction, you can complete that vector, right? Right now you can name this displacement 30 meters towards north. So 30 meters towards north can be written as 30 j cap in a vector format, right? 20 meter towards east, 20 meter towards east can be written as 20 I cap, right? What will you write this vector 30 root 2 towards southwest? So 30 root 2 is the magnitude, and if you multiply that with the unit vector in this direction, right, you can write it in a vector format. So what is the unit vector towards southwest? Think about it. What will be the unit vector towards southwest? First of all, think about it. Unit vector towards southwest. Southwest. Think about it. When you have that, right, then only you can talk about this idea. So you can easily think about this way, right? This is how the southwest is, right? So you can think in this way. This element and this element, the projection is a combination of these two elements, right? So you see that this unit vector in this direction, this is a vector of one magnitude, unit magnitude along this axis. So it's a combination of these two. So it is minus cos 45. This is 45. So minus cos 45 I cap plus similarly sin 45 j cap. Yes or no? Plus sin 45 j cap. I hope that is very, very clear, right? So that's the idea about it, right? Oh, okay, sorry. This minus, because this is also minus and this is also minus, right? So both of them are minus. So minus is outside the bracket. This is the unit vector in this direction, right? This is the unit vector in this direction. So unit vector in this direction is this, right? So unit vector in the southwest direction is this, right? So now you know that if the person is moving 30 root 2 in the southwest direction, so what is the final displacement vector? So d3 you can call it, right? d1 is 30 meters towards north. So d1 is 30 j cap. Displacement 2 is 20 towards east, 20 I cap, right? This is d1, right? d1 vector is 30 through 30 meters towards north. So 30 towards north. North is j cap plus j cap, right? d2 is 20 meters towards east. So 20 times, right? East means I cap, right? And 30 root 2 southwest. So in the southwest direction, this is the unit vector. So 30 root 2, right? And cos 45 I cap and sin 45 j cap. So cos 45 sin 45 is 1 upon root 2. So I by root 2 plus j by root 2. So root 2 can be cancelled out from here. So d3 is going to be minus 30 I cap plus j cap. This is the third displacement. So you have d1 plus d2 plus d3, right? d1, d2 and d3 are given. what is the total displacement. So you see that what is the total displacement? Final position is governed by the vector summation of all three displacements, right? So final position is governed by the vector summation of all three displacements. So when you add all three displacements, you see that this is the D1, we are calling it S1, S2 and S3, right? So when you add all three displacements, right, 30 j cap, 30 units towards north, then 20 units towards east, 20 I cap, and this is the last one, 30i minus 30j. This is what we have already written, right? Minus 30i plus j means 30i minus 30j, right? So over here we have written, and when you solve it, it is minus 10i cap, means 10 units displacement in the direction of minus I cap, means towards west. So 10 units towards west is the answer, right? 10 units towards west is the answer. I believe the idea is very, very clear, right? 10 units towards west is the answer, right? I hope the idea is very, very clear, right, about it. So it's a good question, decent question about it. So first question is just to explain you the concept, right? So first question is explaining you the concept, how to find the displacement vector, right? First question is explaining you the concept about how to find the displacement vector, right? To find the displacement vector, if you are moving from a place where the position vector is r1 towards a place where the position vector is r2, the displacement vector will be r2 minus r1. The displacement vector will be r2 minus r1, and this is how you can figure out, right? Okay. And then we are over here. So a person is moving in this direction, right? So basically the net displacement they are talking about, which is going to be vector summation of all three displacements, right? Okay. So this is how you can find the net displacement in two dimensions. So in the two dimension, first of all, always remember this thing, that the displacement is going to be, or any vector is simply the magnitude into the unit vector in that direction. So how will you write down the displacement of southwest in the vector format, 30 root 2 towards southwest? How will you write that in a vector format? So in the southwest direction, you have to find the unit vector. So take a vector of unit magnitude in the southwest direction and take the component. 45 is this is also. So this is cos 45, this is sin 45. So this is towards I axis, and this is towards j, minus j and minus I. So this is what we have written, cos 45 minus I cap, sin 45 minus j cap, minus is taken out common. So in this direction, the unit vector is figured out, right? So basically, after that, the displacement vector will be in this direction, which is 30 root 2, and the unit vector in this direction is this. Multiply that. So this is the final displacement vector d3, right? So you know d1 vector, d2 vector and d3 vector, if you add them vectorially, you will get the final displacement, which is 10 minus I cap, means 10 units towards west, 10 meters towards west. I hope the idea is very, very clear, right? Okay, Shubha, most welcome. So any problem in this part, my dear kids, right? Let's move on and talk about the next question. If a body gets displaced from 0, 0 to 5, 12, then the magnitude of its displacement is. If the body gets displaced from 0, 0 to 5, 12, then the magnitude of its displacement is. Think about it. First, think about it for yourself for 30 seconds. Try to answer it in the chat box. If you can answer it, it is good. It is good. And if you cannot answer it, I will try to answer it as well. If a body gets displaced from 0, 0 to 5, 12, so both the coordinates are changing, my dear kids, right? Then the magnitude of displacement only you have to talk about, only the magnitude, right? So what is the displacement that you have traveled? Think about it. If it was in one dimension, particle is covering from x equals to 2 to x equals to 10. So you will say final position minus initial position. So 10 minus 2, this is the displacement, right? So magnitude of displacement is 8 meters. And right now we are only moving towards I, towards x-axis. So it is 8 I cap, but magnitude is only 8. Final minus initial, that's what you have done, right? Final position minus initial position. Same thing you have to do over here as well. This is x, this is y. You are moving from 0, 0, right, to 5, 12, right? 5, 12, 5 and 12. All right. So then the magnitude of the displacement is. So what will be the magnitude of this displacement? What will be the magnitude of this displacement? So easy, right? You see that the displacement vector, this is 0i plus 0j, needless to say. This is 5i plus 12j. So what is displacement vector R2? x2 minus x1 I cap plus y2 minus y1 j cap, right? So delta are going to be, displacement vector is going to be x2 minus x1, which is 5 minus 0, which is 5 I cap, plus y2 minus y1, which is 12 minus 0, which is 12 j cap, right? We have to talk about the magnitude of the displacement vector, my dear kids. So it is going to be under root x square plus y square. 5 square plus 12 square, which is 25 plus 144, 169. Under root 169 is 13. All right. So 13 meter is the answer, which is option D. Option D is clear, right? Chemistry teacher, you may look in the previous classes, right? Pratha, I believe Gunjan ma'am will be teaching chemistry to you, right? Okay. Very good, Karthik. Very good, right? Very good, Karthik, beta. Right. Let's move on and talk about the next question. Look at this question and try to solve it. Now we have solved few basic questions already, and now we can solve this question as well. Body is moving from 1 minus 1, then it is passing through this, and this, passing through these 3 points, and then finally it is reaching here. What will be the displacement? Try to solve it. It's a decent question and it tells you one concept, right? Okay. It's a decent question and it explains you one very interesting concept. The question is, if a body is moving from 1 comma minus 1 and passes through 2 comma minus 4 minus 3 comma minus 5 0 comma 2 and reaches 1 comma minus 1, what will be the displacement? So displacement we have to talk about. What will be the displacement? Right? Try to think about it for yourself and try to solve it for 30 seconds. You have to think about. There is a one very interesting concept hidden in this question. Let's see who can figure out the hidden concept in this question. All right, very good, my dear kids, keep on trying. Very good, Deva. All right, so over here, my dear kids, you can say that the displacement is a vector quantity, right? It only depends on the initial position and the final position. If the between, this is the coordinate system, right? X and Y. This is x axis, this is y axis. This is the initial point and this is where the journey ends. This is the final point, right? The displacement vector will be the line joining P and Q. The displacement vector is the line joining the initial point to the final point. This is initial, where the journey starts, and this is final, where the journey ends, right? Now think about it. If there is a point over here, if there is a point over here, if there is a point over here, right? Think about it. It really doesn't matter what points you are passing through, right? And you reach to the final point. It really doesn't matter. The coordinates of these points are already given, let's say, and you are passing through these points. But the displacement vector is still be the same. So we know that the concept is very simple, that the displacement vector between initial and final point is independent of any intermediate coordinates, right? The displacement vector, here you can say that the displacement vector only depends on the initial and final position, right? Only depends on, my dear kids, only depends on the initial and final position. Right? The displacement vector only depends on the initial and final positions, and hence the intermediate points do not affect the displacement vector, right? Points of the journey do not affect the points of the journey, do not affect the displacement vector, right? So you can write it as a note. All right. You can write that as a note, right? So you see that you start from 1 minus 1, you end the journey at 1 minus 1, and these are the points you pass through, right? These are the points you can pass through, right? So what will happen? Let's see, just a second. right? What will happen? Right? The question is very, very clear, right? But again, I have refreshed it, so I believe now it should be much clearer. But anyways, so yeah, you see that these points do not matter. You start and end the journey at the same point. What will be the displacement? We can say that starting point and the final point is same. The displacement will be zero without even looking at it. So this is the concept, right? And these concepts help us develop our understanding, right? Now, we have talked about the displacement in two dimension, right? We in when we were understanding motion in a straight line, we started with displacement, right? So first of all, how will you calculate displacement in one dimension? So here now you are understanding motion in two dimension. So the first term you have to understand displacement in two dimension. What is the next term? We have to talk about the average velocity, which is velocity in two dimension. Now you will be talking about. So my dear kids, previously the particle were only traveling along one axis like this, right? So you said that the displacement over a given time interval will give you the velocity, right? Displacement over the time interval will give you the velocity. And here the displacement is only along this axis or this axis, only one dimension. Here what is happening? The particle is moving from x1 y1 to x2 y2. So in place of displacement, we'll be using this thing, displacement vector, right? So this is the displacement vector. Particle is moving from here to here, from this point to that point, right? So this is the displacement vector, delta r, right? And time taken is delta t. So average velocity will be delta r upon delta t. No problem with that, right? So delta r is basically you are moving from this point to this point. So delta r is x2 minus x1. You know that this is x1 y1, this is x2 y2. So in the beginning of the class already you have seen how to write the displacement vector. Delta r is x2 minus x1 and delta I cap plus y2 minus y1 j cap, or you can say delta x I cap plus delta y j cap, right? So in place of delta r, you can put delta x I cap and delta y j cap, and you divide it by delta t. So delta t is dividing into whole thing, right? So delta x I cap upon delta t, delta y j cap upon delta t, right? So this is the expression you will get, okay? So you see that delta x upon delta t or dx by dt, it is the velocity component along x-axis. dy by dt, this is the velocity component along z-axis, right? If it is delta upon delta t, we are writing about the average velocity because the time interval is larger. And as I have already explained, if the time interval is super small, infinitesimally small, so dx upon dt I cap and dx by dt j cap will be the instantaneous velocity in two dimension. Simple, right? So yeah, this is the average velocity we have written. If the delta t is limiting towards 0, very small, so we have dx by dt I cap and dx by dt j cap, right? Okay, so delta t is very, very small. Think about it. This is the vector you can cover in delta t time. So if the time is approaching towards 0, so what will happen? This arrow will be getting shorter and shorter. The time span you will get shorter and shorter, right? So you are talking about a very short interval, and basically you are talking about the instantaneous velocity. So this is the instantaneous velocity. And on a 2D curve, if a particle is following a certain path, what is the direction of instantaneous velocity? So here we can say that just tangential to that point, right, is the direction of instantaneous velocity at that point, and the direction of tangential velocity over here is this much, right? So yeah, we have written it, right? Okay, all right. So yeah, we can say that over here, this is the instantaneous velocity vector over here, right? Let's say that at this particular instant, the velocity vector makes an angle theta from the horizontal, right? So horizontal component of the instantaneous velocity will be Vx and vertical component is Vi. So what will be the value of Vx? We can say V is V cos theta and Vy is V sin theta. So instantaneous velocity has two components, V cos theta and V sin theta, horizontal component, vertical component, right? So you know that if you want to write down the instantaneous velocity, it will be horizontal component Vx I cap and Vy j cap, right? What is this? You look at that, dx by dt is Vx and dy by dt is Vy, right? So instantaneous velocity is Vx I cap plus Vy j cap, right? Okay. So you see that what is Vx? It is V cos theta. What is Vx? It is V cos theta. So V cos theta I cap, and it is V sin theta j cap. I hope that is very, very clear, right? So now you can say that, okay, this is the entire vector thing, right? This is the vector, instantaneous velocity vector. What will be the magnitude of this thing? So we can say magnitude is this square plus this square, under root this square plus this square, right? Under root Vx square plus Vy square is the magnitude of this velocity, and direction tan theta. What is the direction? So Vy upon Vx is the direction of this thing. All right. Now look at this vector. Position vector is given as 5t square I cap and 60 j cap, where t is in seconds and r is in meter. Find the velocity at t is equals to 0, right? Look at this expression and try to solve it. Which formula? Dark aura. You cannot see half of the screen. You just refresh the app, my dear kid, huh? Right. So over here, what will happen? Think about it. Look at this numerical and try to solve it. R vector is 5t square I cap plus 60 j cap. T is in seconds and r is in meter. Find the velocity vector at t is equals to 0. Find the velocity vector at t is equals to 0. So think about it and try to solve it. Right. Simple numerical. You should be able to solve it directly based on the concept we have understood. Right. So you see that the position vector is given as 5t square I cap plus 6t j cap. If you see that the position is changing with time, right? Position is changing with time, and this is given already to you, right? So clearly you can talk about the velocity. So r vector, position vector is given. Velocity will be dr by dt. This is going to be 10t I cap plus 6 j cap, right? Differentiate this and you will get this expression, right? So what will be the velocity at t equals to 0? What will be the velocity at t is equals to 0? Right? It is going to be 10 into 0 I cap plus 6 j cap, right? So it is 0 plus 6 j cap, only 6 j cap will be the answer. Velocity at t is equals to 0 will be this. Velocity at t is equals to 0 will be this. So I believe the idea is very, very clear. Option A is going to be the correct option, right? Option A is going to be the correct option, right? All right. So let's keep on moving and keep on talking about the next ideas, right? I hope everything is very, very clear till now, right? बोलो बेटा पूजा, बात समझ में आ रही है? Pooja, is that clear, everybody? All right. So let's keep on moving and talk about the next idea. Look at that, slightly better question than the previous one. The position vector of an object changes from 3i plus 4j to 9i plus 12j in 2 seconds. Its magnitude of average velocity is, right? You see that the position vector is changing from this to this. So you see that the initial point has a position vector 3i plus 4j. Final point has a position vector 9i plus 12j, right? All of this is happening. We are moving from here to here in how much time? 2 seconds, right? Its magnitude of average velocity is, what is the magnitude of average velocity? We have to talk about that. We have to talk about the magnitude of average velocity. We have to talk about magnitude of average velocity. All right. Think about it. What will be the magnitude of average velocity? Very simple question. We have just seen the formula for average velocity, right? You know that average velocity will be displacement upon time, right? So we are moving from this place to this place. So the displacement vector will be r2 minus r1 upon time. So 9 minus 3 is 6. 12 minus 4 is 8. And time is how much? 2 seconds. So it is 3i minus 4j, right? Yes or no? I hope the idea is very, very clear. All right. 9 minus 3 is 6 and 12 minus 4 is, oh sorry, it should be plus 8. So plus 4. Yeah, it is good now. So now we can talk about it. So clearly, the magnitude of average velocity will be under root this is square plus this is square, under root 3 is square plus 4 is square. So 9 plus 16 is under root 25, which is 5. Okay. So 5 meter per second is the answer, which is the option A. That is correct, right? So I hope the idea is very, very clear. So this is something velocity in 2 dimension, right? This is something that we call as velocity in 2 dimension, right? Okay. Right. Focus, Aryan. So over here we have it. An object moves 15 meter east, 8 meter north in 4 seconds. The magnitude of average velocity of this object is, think about it. We have to talk about the average velocity of this object. He is moving 15 meter east, right? Then he is moving 8 meters north, 8 meters north, and all of this displacement is covered in 4 seconds. The magnitude of average velocity of the object is, what will be the magnitude of average velocity? This is something we have to talk about. What will be the magnitude of average velocity? So you know that average velocity, first of all, in the vector format is delta r upon delta t, right? So the magnitude, first of all, figure out this much, and magnitude you can easily figure out after that, right? Think about it, my dear kids. All right. Object is moving 15 meter I cap, 15 meter towards east. So basically we can say that the displacement over here is 15 I cap 2, because towards east the unit vector is I cap, then 8 meters north. So 8 j cap. This is the final displacement, right? This is the total displacement. And we have to divide it by time, which is 4 seconds, right? So we can do this thing also, right? We can also do this thing that the displacement, instead of using the displacement vector, we can get the magnitude of displacement and divide by 4 seconds, right? We can get the magnitude of displacement and divide by 4 seconds. So what is the magnitude of displacement, right? We can also do this thing. That will be a lot easier, because we just have to give the displacement magnitude. So you see that magnitude of displacement will be, right, here the displacement vector is 15i plus 8j, and magnitude of displacement will be under root 15 square plus 8 square. So under root 225 and 64, right? So which is under root 225 and 64, which is under root 17, right? I believe it is correct. So I hope the idea is very, very clear. So the displacement in this situation is going to be 17 meters, right? The displacement in this situation is going to be 17 meters, right? And the displacement you are getting in 4 seconds. So the time involved is 4 seconds. So what will be the velocity magnitude? Magnitude of average velocity is going to be delta r upon delta t, right? So you see that this is 17 and time is 4. So 17 upon 4 is given the decimal point. So it is 4.25 meter per second, which is option D, and that is the correct option, right? I hope the idea is very, very clear, right? Let's keep on moving and talk about the next idea. All right. Yes, beta Sanjana. Hello, beta Aryan. Hello, Seema. All right. So let's continue and talk about the remaining ideas, my dear kids, right? Okay. So look at the question and try to solve it, my dear kids. This is the new question. The position of a particle given is this: 3t I cap, 2t square j cap, 5k cap, where t is in seconds and the coefficients have proper units for r to be in meters. Okay. Find the magnitude of velocity at the time t if at t is equals to 1 second. So first of all, r vector, the position vector, is given as a function of time. You see that 3t I cap, 2t square j cap, and 5k cap, right? This is the position vector which is given to us. We have to talk about the velocity, right, at t is equals to 1. We have to talk about the velocity at t equals to 1. Think about it. First of all, you need to think, first of all, you need to think uh, how to get the velocity vector from this thing. So we can differentiate dr by dt, and that will give us the velocity vector. So it is going to be 3i cap and 4t j cap, and 5k cap is 0, right? So we have to talk about the velocity, magnitude of velocity at t is equals to 0. First of all, what will be the velocity vector at t equals to 0? So 3 into I cap plus 0 j cap, right? Put t is equals to 0 over here. So magnitude of velocity at t is equals to 0 will be under root 3 square plus 0 square, which is under root 9, which is going to be 3, right? So 3 meter per second is going to be the answer in this situation, right? Hmm. Okay, t is equal velocity at t is equals to 0. No, we have to find the velocity at t is equals to 1. Sorry. So I have found the velocity at t equals to 0. No problem. We can put t is equals to 1. We will get the velocity at t equals to 1. So we can put t is equals to 1 over there. So you will get the velocity expression 3i plus 4 into 1, which is 4j cap, right? So we can get the magnitude of t velocity at t is equals to 1 under root 3 square plus 4 square. No worries about that. 9 plus 16 under root 16, which is 5 meter per second. So that can be corrected. We have to find the velocity not at t is equals to 0. We have to find the velocity at t is equals to 1 second, right? I hope that is very, very clear. Simple question. Right. Now, we have talked about the displacement in 2 dimension. We have talked about the velocity in 2 dimension. Now, the next term automatically is acceleration. Now, the next term automatically is acceleration. And here we need to discuss acceleration in 2 dimension. Here we need to discuss acceleration is in 2 dimension. Right? Here what do we need to do? We have to talk about the acceleration 2 dimension. My dear kids, we are understanding motion in a plane. And just like we started motion in a straight line, and we understood that first of all we have to talk about motion, terms of motion, right? Which is displacement, velocity, acceleration, all those things. Here we are starting motion in 2 planes, right? Okay, motion in a plane. There we studied motion in a straight line, right? So motion in a plane means x-axis and y-axis both are going to be involved. Since we have both axes involved, we have to talk about displacement in 2 dimension. We have to talk about velocity in 2 dimension. Similarly, we have to talk about acceleration in 2 dimension, right? We have already talked about displacement in 2 dimension. We have already talked about velocity in 2 dimension. Now we are here. We are talking about acceleration in 2 dimension. Now we are talking about acceleration in 2 dimension, right? Let's have a discussion on that. Who is going to teach zoology? I believe zoology will be taught by, I guess, Ayushi ma'am, if I'm not wrong. Right? You can check with that. I guess she will be teaching you the zoology part. Okay. So this is something we have, right? So let's keep on moving and talk about the next idea. Okay. So here you see that particle is moving, and since we have instantaneous velocity like this, we have instantaneous acceleration like this, right? So you see that instantaneous acceleration is having this particular value. Okay, let's have a look at that. So see, right, the direction of velocity and the direction of acceleration need not to be the same, right? This is something very important, and this is something you have to understand, right? Many kids say, if I ask them, the path of body when it is moving is like this, right? This is how the body is moving, right? At this particular point, what will be the direction of velocity and what will be the direction of acceleration? Think about it. This is a clear case of projectile motion. So here we can say with the confidence that the body at this particular instant, instantaneous velocity is going to have this direction, right? But the acceleration is not in this direction, because the only force that is acting when the body is in the air is the gravitational force. And if the gravitational force is there, so body is attracted in this direction only. So see that acceleration and velocity at this point are not in the same direction, and they are not bound to be in the same direction, right? So in two-dimensional motion, we can have acceleration in a different, along different axis, and velocity along different axis, right? Okay. So far what was happening in the previous chapter, when we were studying motion in one dimension, body was moving like this. Either we can have acceleration like this, or we can have negative acceleration or retardation just in the same line of action in the opposite direction, right? Here in two dimension, acceleration and velocity need not to be along the same line of action, right? Here you can see in the projectile motion, gravity is pulling the body downward and it is accelerating like this, right? It is accelerating like this. I believe the idea is very, very clear. Seema, that is a separate class, a vector class, right? That's a different class, Seema, right? In the vector class, I will explain that. For now, you can focus on this particular part, my dear kid, okay? So over here, we have understood that in a two-dimensional motion, velocity and acceleration are not in the same direction, need not to be in the same direction. So what are we doing? Let us say that this is how a random, not projectile motion, this is how random two-dimensional motion is happening. And at this particular moment, this is how the velocity is, right? And the acceleration is along a different axis. This is how the acceleration is, right? And this acceleration has two components, this and this. A horizontal component and a vertical component, right? So we can talk about this part right now. A horizontal component along x-axis is ax and vertical component is ay, right? So at particular moment, at any given moment of body performing a two-dimensional motion, acceleration is a, horizontal component of the acceleration is ax, and vertical component of the acceleration is ay, right? So think about it, acceleration is going to be ax I cap plus ay j cap, right? X component ax I cap plus ay j cap, right? That's how you will write acceleration. Now acceleration is how quickly the velocity changes, rate of change of velocity, dv by dt. So you can say that dvx by dt I cap plus dv by dt j cap, right? Why? Because the velocity vector you have just figured out, the instantaneous velocity was dx by dt I cap and dy by dt j cap. In the previous pages, you have already studied that. So velocity vector is dx by dt is vx I cap and dy by dt is vy j cap, right? So think about it. If in place of velocity vector we are putting like this, so what will happen? Just differentiate the whole thing, d by dt, dv by dt we want to figure out, right? So d by dt of this whole thing. So basically dvx by dt I cap and dvy by dt j cap. This is expression of acceleration, right? This is the expression of acceleration. So if a particle's velocity is given, right, how will you find out the acceleration expression, right? How will you find out the acceleration expression? So you can say that dvx by dt I cap, dvy by dt j cap, right? All right, so this is the acceleration given to you, ax I cap plus ay j cap. Okay, look at that. The velocity of a particle changes from 7 I cap meter per second to 8 j cap meter per second in 1 second, right? So velocity is changing from 7I to 8j. So initial velocity vector is 7I cap meter per second, my dear kids. And finally, the velocity vector is 8j cap meter per second, right? In 1 second. So all of that change is happening in 1 second, right? The acceleration is, so what will be the value of acceleration? What will be the value of acceleration? This is something we have to talk about. What will be the value of acceleration? So think about it for 30 seconds, right? Think for yourself for 30 seconds, right? Oh, great. Harman, very good, right? Keep on learning and you'll be a master of physics as well, right? Very good. Okay. So what is really happening, my dear kids, over here? Initial velocity vector is given 7I, final velocity vector is given as 8j. We have to talk about what will be the what will be the acceleration in this situation? So you see that initial velocity vector is along this axis, final velocity vector is 8j along this axis. So motion is not happening along one line, it is happening first like this and then like this. So motion is happening in more than one dimension and it is happening in two dimension. Here we have to calculate the acceleration. So what is acceleration, my dear kids? Acceleration is rate of change of velocity. Yes or no? Acceleration is rate of change of velocity, which is change in velocity upon time. So this is final velocity minus initial velocity upon time. Final velocity is 8j cap, initial velocity is 7I cap, and time is 1 second. So we have 8j minus 7I, that is going to be meters per second square, right? Minus 7I plus 8j, or you can write it, just rewrite it, minus 7I plus 8j. This is going to be your option, right? This is going to be your answer. Any problem in this part, my dear kids? I believe the idea is very, very clear till now, right? If you have any problem, you can ask me. Okay, very good. Awesome, very good, everybody. So let's talk about the next question, my dear kids. This is the next question. The x and y coordinates of particle in a planar motion are x this and y this, right? You see that the particle is performing a two-dimensional motion. So far you were calculating acceleration, velocity and displacement in one dimension. Now you are doing the same thing in two dimension, right? So here the x is 5t square minus t square, x is 5t minus t square, right? Okay. And y is 10t, y is nothing but 10t, alright? Okay, the acceleration of the particle at t is equals to 1. What will be the acceleration of the particle at t is equals to 1 second? Okay. What will be the acceleration of the particle at t is equals to 1 second? Alright. So over here, let's focus on this particular idea. We have to talk about the acceleration. First of all, just for 20 seconds, think for yourself, like how to go about the acceleration. We know the displacement in x and displacement in y is changing with time. So what will be the acceleration? Think about it. Just when you think about it for yourself, then you can figure out with the clear ideas, right? Then you start learning. When you start thinking, then only you can start learning. So displacement along x-axis is given, displacement along y-axis is given, right? You have to talk about the acceleration, right? So now, looking at the displacement along x-axis, if we differentiate that, you will get velocity along x-axis, yes or no? So you have 5 minus 2t, okay? And if you further differentiate that, you have 0 minus 2, which is minus 2, right? So this is the acceleration along x-axis, right? Similarly, you have the displacement y is equals to 10t, right? Differentiate that, Vy is dy by dt. So velocity in the y direction will be a constant. Differentiation of 10t is 10. So velocity in the y direction is a constant. That means there will be no acceleration. Differentiation of 10 is going to be 0. Acceleration in the y direction is dvy by dt. So that is clearly 0. So see that acceleration in an x-axis we know, y-axis it is 0. So clearly acceleration is going to be from this particular idea, right? Acceleration you can talk about from this idea, right? So x-axis is this, y-axis is this, right? The final expression of acceleration is ax I cap plus ay j cap. So you have minus 2 I cap plus 0 j cap, and we can say that 2 into minus I cap, minus 2 I cap, which is unit acceleration magnitude is 2 and direction is towards minus I, which means towards negative x-axis, right? So minus 2 I cap meter per second square is the value of acceleration, right? I hope the idea is very, very clear, right? Look at this expression. The direction of acceleration in two-dimension motion is the direction of, right? The direction of acceleration is the direction of which of the following thing? We can say that, sir, acceleration is change in velocity upon time, right? So you see that initial velocity could be in any direction, final velocity could be in any direction, right? But the change in velocity vector will decide the direction of acceleration, because acceleration is change in velocity vector upon time, right? So change in velocity vector, that will decide the direction of acceleration, right? Change in velocity vector, that will decide the direction of acceleration. So option C should be clear. Right. Very good. So one kid is asking a question. Yes, I'm seeing your message, Himanshu. All right. Seema is asking, sir, a football is kicked at an angle 0 degree with the ground. Its vertical component will be 0 or infinite? 0. Because you are kicking 0 degree from the where is your question? Okay. Seema, okay, so I saw your question, right? So 0 degree from the horizontal. So basically you are kicking it along the horizontal, right? So there is no vertical component, right? Okay. Now look into this question, right? We have a velocity and acceleration of a particle. Velocity vector is this, acceleration vector is this. Find the velocity and displacement of the particle at t is equals to 2 seconds, right? We have the velocity and acceleration of a particle at t is equals to 2 written like this. Find the velocity and displacement of the particle at t is equals to 2 seconds. Think about it. Find the velocity and displacement of the particle at t is equals to 2 seconds. So you see that initial velocity is given, acceleration is also given. So with the acceleration, the velocity will keep on changing, right? With the because you see that the velocity at t is equals to 0 is given, initial velocity is given 2y plus 3j, and there is an acceleration as well. So velocity will keep on changing, and if you focus, acceleration does not depend on time, it's a constant acceleration. So it will keep on changing with time. We have to talk about the velocity and displacement of the particle at t is equals to 2 seconds. We have to talk about velocity and displacement of the particle at t is equals to 2 seconds. It's a good question, right? Okay, so we can talk about it. Think about it. Think about for yourself for 10 seconds, right? The question is good. By looking into the question, it is clear that the acceleration is constant and initial velocity is also given to you, right? Since the acceleration is constant, so over here we can say that acceleration is 4i plus 2j. Acceleration is 4i plus 2j. You see that it does not depend on time. So we can say that it's a constant acceleration. My dear kids, since the acceleration is constant, we can say that it's a uniformly accelerated motion. Uniformly accelerated motion. And once the motion is uniformly accelerated, you can apply those same equations of motion. Those equations of motion of uniformly accelerated motion, v is u plus at, s is ut plus half at square, v square is u square plus 2as. All those equations are equally valid in this case as well, right? Very good question. Okay, and you see that the initial velocity is 2i plus 3j. Initial velocity is 2i plus 3j, right? We have to talk about the final velocity. So you know that v is equal after how much time? After 2 seconds. Final velocity after 2 seconds. So v is equals to u plus at. Here final velocity vector, put everything in the vector format, right? And this equation is still holds true. Final velocity vector, because my dear kids, you have to get the final velocity vector, which is why I'm using this equation in the vector format, right? If they were asking, if they were giving the final velocity in the magnitude form, I would have gone for the acceleration's magnitude, velocity's magnitude, and I have only used the magnitudes of these things in the equation, right? since they are giving it in the vector format, I'm using it in vector format, which is more appropriate, right? So like in fact, even if they were giving the magnitude, even if they were asking the magnitude of velocity, I wouldn't have converted acceleration velocity over here. Rather, I would be putting in a vector format. I will finally get the velocity vector, which is a lot easier, and I will be solving only 1 under root. Otherwise, I'll be solving 1 under root here and 1 under root here, right? So you see that velocity vector is going to be u vector plus a vector. So u vector is given 2i plus 3j plus acceleration vector is 4i plus 2j, and time is how much? Time is 2 seconds, right? We have to talk about, you see that velocity of the particle at t is equals to 2 and also this displacement. So you see that the velocity vector will be 2i plus 3j plus 8i plus 4j, 10i plus 7j. I hope the idea is very clear. This is the velocity vector, 10i plus 7j. 10i plus 7j is the velocity vector. So by the way, only one option carries this thing for this option for the velocity vector, and rest of the options are not carrying it, but no problem. We can talk about it, right? So velocity vector is written displacement of the particle. So displacement of the particle, similarly you can figure out as, you see that this s is ut plus half at square. Okay, so everything you have to put in the vector format. Displacement vector will be initial velocity vector, which is 4i plus 2j, right? Time is 2 seconds, half at square. Acceleration vector is 2i plus 3j, right? And time is 2 square, so it is 2 into 2, right? So multiply that, 8i cap plus 4j cap plus 4i cap plus 6j cap, right? So 8i and 4i is 12i cap, 4j and 6j is 10j cap, all right? 12i cap plus 10j cap. This is the displacement vector, right? This is the velocity vector, right? 12i plus 10j, that option is also matching up. So no problem, option C is going to be the correct option, right? Okay. I hope the idea is very clear, right? All right. I hope the idea is very clear, right? So let's keep on moving and talk about the remaining ideas. All right. Now we are starting the journey of projectile motion, right? Now we are starting the journey of projectile motion. Okay. All right. So start from here. So far what we have discussed, my dear kids, we have discussed the terms of two-dimensional motion without a problem, right? Terms of two-dimensional motion, this is what we have discussed. Now we are entering into the second part, which is projectile motion, right? So what are the terms that we are going to talk about in projectile motion, right? You see that. First of all, let me explain you the concept of projectile motion. Projectile motion. And my dear kids, we are going to talk about projectile along the horizontal plane, right? Projectile motion can happen in different cases, but what we are going to talk about, projectile motion along a horizontal plane, okay? So projectile motion is, you see, when a body is launched at an angle theta from the ground, the motion it performs is called as projectile motion, right? If the theta is less than 90 degree, so if the launching angle is less than 90 degree, then in that case what will happen? The body is launched, this is the initial velocity of the body, and it is launched at an angle theta. So it moves like this, and it falls somewhere like this, right? This motion of the body is called as projectile motion, right? Because the body is moving like a projectile, right? Now you focus on this particular idea. Once the body is leaving your hand, even if you are, to provide the velocity you are applying some force in the beginning, right? But when the body leaves your hand with the initial velocity u, right, then you cannot touch the body. Once the body leaves your hand and it is moving, you cannot do anything, right? The body is launched with some initial velocity, and then there is no interference by any other object, any other force applicator other than one, right? You see that nobody can apply the force in the journey of the projectile motion. Only one thing can apply the force, that is earth itself. So when the object is moving and it is here, the earth is pulling the body downward, it is the gravitational force. The object is over here, the earth is pulling the body, object is over here, the earth is pulling the body, object is over here, earth is pulling the body, object is over here, earth is still pulling the body, right? You see that at every point earth is pulling the body, right? So projectile motion is happening under the action of only one force, which is gravitational force, right? And if the projectile motion is happening near the surface of earth, if the projectile motion is happening near the surface of earth, we know that, my dear kids, that if this is earth, right? So if at a certain distance away from earth, the value of g changes, the value of acceleration due to gravity keeps on changing, right? But if you are moving very close to the surface of earth, let's say 300 meter, 400 meter, the radius of the surface is 6400 kilometers, right? So you see that you can continue to go up, right? And let's say at 2000 kilometers away from the ground, there will be a different value of acceleration due to gravity. But if the motion is happening at 2, 3, 4, 500, 600 meters from the surface of earth, radius of earth is 6400 kilometers, and motion is happening at just 3, 4, 500 meters above the surface of earth, right, or less than that. So we can say that the value of g will not vary that much. So all of that motion, where the body moves up and comes down, all of this motion is happening under a constant force. You see that if the body was moving at a really large height, m into g dash, the value of g will change, so the force that is acting on the body will change. The value of g will change, so the force which is acting towards earth, that will also change, right? We know that, right? So the value of acceleration due to gravity is going to change, right? Which is why the force will change. So this motion is under variable force, right? But if the projectile motion is very close to the surface of earth, the entire motion is under a constant force, which is the gravitational force, right? So this is the assumption that whatever projectile motion we are studying, in that case the body is moving closer to the surface of earth, right? Closer to the surface of earth. Any problem, my dear kids? Arpita, Sagar, clear? All right. Okay, so now what is happening? You see that if a body is moving in this direction and there is no acceleration in this direction, there is no acceleration along this axis, what will happen to this component of velocity? Let's say the initial component in this direction is u, 50 meter per second. Let's say it is 50 meter per second and there is no acceleration, so it will remain 50, right? So in a direction, if there is no component of acceleration, that component will not be affected. So that velocity will not be affected, right? My dear kids, if let's say the acceleration is acting on the body in this way, so we can say that a component of acceleration will be a cos theta. It will be along the velocity, and this component will change the velocity magnitude. It will make it faster, right? And this component of the velocity, u sine theta, this has no effect on the component of velocity, right? So my dear kids, if a body is moving like this and the only acceleration is like this, so this acceleration has no effect on velocity in this direction, right? This acceleration can only change the direction. I should not say it has no effect, rather I should say it has only one effect, which is to change the direction of the velocity. This acceleration cannot change the magnitude of velocity. This acceleration can only change the direction of the velocity, as it happens in the when you tie a body in a with your finger and rotate it in a circular path. So what is really happening? A force is acting in this direction, and the body is, moving in this. Let's say it is moving with a constant speed, right? So speed is constant like this, right? And force is acting towards the center. So force is always perpendicular to the velocity. Velocity is tangential, right? And force is perpendicular to that. So this particular force is not making the body faster or slower. This force is only keeping the body on a circular path, right? You see that the body next second will come up over here. Now the direction is like this, right? So how the direction of the body changed? Initially it was this and now it is this, right? And over here the body's direction is this, right? So how the direction of the body's velocity is changing? Because there is a force acting perpendicular to it all the time, right? So force which is acting perpendicular to the velocity has only one effect, that it can change the direction of the velocity, and force which is acting along the velocity, only that force can change the magnitude of velocity, right? Now understand that when you are launching the body at an angle theta, right, in this direction there is a gravitational force, right? So my dear kids, if I make two components of the velocity in the beginning, it is u cos theta and it is u sin theta, right? Now if you think about it, what is happening to u cos theta? Think about it. Particle is over here. It has some horizontal velocity and some vertical velocity. Some horizontal velocity, and the particle is moving up. So it has some vertical velocity as well. Now think about it. Is there any force? Only one force is acting, gravitational force. Is there, this force has no component in this direction, right? So this particular force cannot change the magnitude in this direction, magnitude of velocity in this direction. Again, the horizontal component is over here like this, and the force is still here. Force is always like this. So again, force is always perpendicular to the horizontal component of velocity. So the force cannot affect this component, right? So in the projectile motion, the gravitational force is acting only in the projectile motion. And since the gravitational force is perpendicular to the direction of velocity, this particular gravitational force cannot change the magnitude of horizontal component, right? So horizontal component everywhere remains as it is. This force is acting, but horizontal component remains as it is. What will happen with the vertical component? Vertical components will get affected. You see that initially the vertical component is, let's say, this big, right? Now, since the force is acting downward, velocity component initially it upward, right? So it will reduce, right? So now it is a smaller vector, or you can make it slightly bigger so that rest of it can be drawn, right? So this is smaller, reduced, right? Now again from here to here, still the force is acting, it will even make it smaller. Again, vertical component is reduced, right? And you see that the velocity component, the vertical direction is reducing, right? Over here, what will be the vertical component? You see that the particle is moving up because of the vertical component of the velocity. Particle is moving forward because of the horizontal component of the velocity. And at the topmost point, velocity does not become zero. It is only the vertical component of the velocity that becomes zero, right? At the topmost point, at the topmost point, point at the topmost point, only the vertical component of the velocity becomes zero. Vertical component of the velocity becomes zero, right? Horizontal component remains as it is. If there was no horizontal component, think about it. If there was no horizontal component over here, then covering this journey was not possible, right? The body is here and it has no velocity, neither horizontal nor vertical. So it will simply fall. Since it has a horizontal component, so it continues to keep on moving. Now, what happens? Because the force is still acting downward, now the velocity vector increases in the downward direction. Now it increases even further in the downward direction. Now it increases even further in the downward direction, right? So I believe the idea is very, very clear. In the journey of projectile motion, what really happens? In the journey of projectile motion, what really happens? In the journey of body performing a projectile motion, what really happens? This is the force, this is theta, this is the force, this is the force, right? When a body is performing the projectile motion, right, it is launched at an angle theta, and theta should be less than 90 degree. When a body starts a projectile motion, its initial velocity can be considered into two components: horizontal component u cos theta and vertical component u sin theta. The force which is acting in the journey of projectile motion is only the gravitational force, and which is mg. Since this force is acting vertically downward, so it only affects the magnitude of vertical velocity, and it does not changes the magnitude of horizontal velocity. So in the entire journey of the projectile motion, once it starts and before it hits the ground, in the entire journey of the projectile motion, the body's horizontal component remains as it is. So at all points, the horizontal component is u cos theta. Even at the topmost point, the horizontal component remains. The vertical component becomes 0. Right? So everywhere horizontal component is u cos theta, everywhere, right? And the vertical component keeps on changing because there is an acceleration, and because of the force mg, there is an acceleration g, right, in the vertical direction, and that vertical component keeps on changing, right? So this is what happens in the projectile motion, right? Neeru, my dear kid, for vector we are going to have a separate lecture, right? Okay, I thought vectors must be already covered, but no issues, right? If I was teaching you only vectors, then this class would be required only for vectors only, right? But I can explain you vectors in a brief, right? Let's say in a 1 hour lecture, I can schedule it someday. Okay, all right. So projectile motion is this, right? So let's write down the conclusions that we have, right? First thing, first thing of the projectile motion is the launch angle must be less than 90 degree, then the body will perform projectile motion. Number 2, horizontal component remains unaffected during projectile motion, right? Third thing, we are assuming, my dear kids, we are assuming the motion is happening, right? Just a second. So third thing is, we are assuming the motion is happening near the surface of earth, near, motion is happening near the surface of earth, we are assuming the motion is happening near the surface of earth, so the gravitational force can be considered constant, all right? Okay, and this is very, very important for us to understand, because if we don't assume that, we won't be able to solve the projectile motion very easily, right? It will be extremely tough problem in that case, right? Since the motion of the projectile motion, since the motion of projectile is happening closer to the surface of earth, you can say this height is ignorable as compared to the radius of earth, 6400 kilometers. So the variation in the value of g is not that much, and everywhere the force which is acting is gravitational force, mg is constant, right? And since the force is constant, the acceleration caused by the force is constant, right? Constant force will create constant acceleration, right? So acceleration is force upon mass. If force is constant, right, acceleration created by the force will also be a constant force, constant acceleration, right? So my dear kids, in the projectile motion, there could be two parts. Motion can be described into two parts, right? In projectile motion, this is very, very important. Motion can be described in two parts, right? In projectile motion, motion can be described or motion can be divided into two parts. I did into two parts. All right. The first part is the horizontal motion. So in the horizontal motion, my dear kids, when the projectile motion is happening on the flat surface, right? Along the horizontal axis, there is no force along this axis, right? So we can say that along horizontal motion, the net force along the horizontal motion is 0. So since there is no force along the horizontal motion of the projectile, in this direction there is no force. So what will happen? There will be no acceleration along the horizontal axis, right? So horizontal motion has no acceleration, and if any particular motion has no acceleration, we can consider that as uniform motion, right? So in projectile motion on a flat ground, the horizontal component of the motion is a uniform motion. So this is a very interesting conclusion. So the horizontal component of the projectile motion is a uniform motion. Again, when it is happening on a flat ground, right? The horizontal component of the projectile motion is a uniform motion. The horizontal component of the uniform projectile motion is the uniform motion. So we have understood that particular part. And if you talk about the uniform motion, the particle has initial, let's say, particle has initial velocity ux. In the time t, how far it will go, right? In the time t, if the particle starts horizontally, let's say particle is starting, the initial velocity is ux. In the time t, how far it will go along x-axis. So how far will it go along x-axis? So we can say that distance traveled along x-axis in the time t is equals to initial velocity is x component of the initial velocity into time t, right? If the particle stays in the air for the total time capital T, it is called as time of flight, right? If the particle stays in the air for a total time capital T, so what will be the total end to end distance? How far the particle will go? Particle stays in the air for the total time T, it is launched, and then when it simply touches the ground, the total time taken is T. So for the time T, it was in the air and it was moving forward, right? So how far it will move? So what will be the range? So range is because of the horizontal motion, ux into the time, total time is T, right? So basically we can say that total range is going to be, range of the projectile is going to be x component of velocity into the time of flight. I believe the idea is very, very clear, right? Okay, so this is about the horizontal motion, and this is where we have figured out that what will happen because of this thing, horizontal component, right? This is the analysis of the horizontal motion. Second is vertical motion, right? My dear kids, when we talk about the vertical motion of the projectile, the vertical motion of the projectile is when it is happening near to the surface of Earth. Vertical motion of the projectile is uniformly accelerated, right? In the vertical direction, here you have studied that we are assuming the motion is happening near the surface of Earth. So the gravitational force is considered constant. So here we can write down, since the gravitational force is considered constant during the projectile motion, so you see the body is launched at a velocity u, horizontal component is going to be u cos theta, it is launched at an angle theta, vertical component is u sin theta, it will simply move like this, right? So clearly you can say that Fg is constant. The gravitational force on the body is always a constant. Since the gravitational force is constant, we can say that acceleration due to gravity will also be a constant. Acceleration due to gravity will also be a constant in this situation, right? Acceleration, I should say, in the vertical direction should also be a constant. Acceleration, I should not call it AG, I should call it acceleration in vertical direction. Vertical direction, that is a constant. Force in a vertical direction is constant, so acceleration in vertical direction should also be constant, right? So yeah, right, force in vertical direction is constant, so acceleration in vertical direction is also constant. So vertical motion is uniformly accelerated motion, right? Vertical motion is uniformly accelerated motion. So basically we have understood that in the projectile motion, horizontal motion is uniform motion, distance is velocity into time, and vertical motion is uniformly accelerated motion, right? Okay. And since it is uniformly accelerated motion, we can apply three equations of motion in this. V is u plus at, right? Here all elements are in the y direction, vertical direction. S is ut plus half at square. Displacement in y direction is initial velocity in y direction and acceleration in y direction, right? And v square is u square plus 2as. And again, everything is in y direction, right? So in vertical direction, since the motion is uniformly accelerated, equations of uniformly accelerated motion are applicable in the vertical direction. In the horizontal direction, since the in the horizontal direction, since that is happening in the horizontal direction, okay, cells are finished. In the horizontal direction, what is happening? In the horizontal direction, since there is no net force, so the motion is going to be uniform motion. And this is something very critical to understand the projectile motion. This is something very critical to understand the projectile motion, right? Ways to best. Beta, I'm explaining you this idea, like how to figure out the height, distance, object, time, flight. All of that I'm explaining you, right? Okay, don't worry about that. Okay. So right now, my dear kids, there are certain parameters, as the kid is asking as well. There are certain parameters, right? The first parameter is time of flight. Okay. Time of flight is the time for which the body stays up in the air, right? The body is launched, right? So it is leaving the ground, and then before it touches the ground, it stays in the air for a while. The total time for which the body stays up in the air is the time of flight. Second thing, if you are launching the body at an angle theta with the initial velocity u, it will definitely go to a certain maximum height, h max, right? If you definitely change the angle, the h max will change. So you can talk about maximum height of projectile. Maximum height of projectile, right? And the third thing we can talk about is how far the projectile is landing once it is launched. So this distance, this is called as range of projectile. What do you call it, my dear kids? This is called as range of projectile, right? The point distance between the initial point and the place where the projectile lands, right? Range of projectile. My dear kids, with the proper analysis, we can figure out any of these things. Now think about it. There are two motion, horizontal motion and vertical motion, right? With common sense, think about it, which motion is responsible or which motion should be analyzed to calculate the range. Range is along the horizontal axis. So which component should be analyzed to calculate the range? We can say that it is along the horizontal axis. So horizontal component is responsible for the range, right? So range, to calculate the range, we will be analyzing the horizontal motion of the projectile. Okay. Which component of is responsible for keeping the body in the air for the time of flight, T, right? Which component is responsible for keeping up in the air, right? So we can say that it is the vertical component. Which component keeps the projectile in the air? Vertical component. Right. Time of flight. So this is the vertical component. All right. You can analyze the vertical component, then only you can calculate the time of flight. Maximum height of projectile, which component is responsible for maximum height? Is it the horizontal component? No, it is the vertical component. So again, to calculate this also, we will be analyzing the vertical component of the motion, right? So you see that projectile motion we can break into two parts, horizontal and vertical. This I called as breaking the projectile motion, so that based on the requirement, right? So our requirement is such, we want to calculate the range. So definitely we have to analyze the horizontal motion. Our requirement is such, we have to talk about the time of flight. So for that we have to analyze the vertical motion, right? So I believe the idea is very, very clear. Okay. All right. I hope the idea is very, very clear. Right. Let's keep on moving and talk about the next idea, my dear kids. All right. Let's keep on moving and talk about the next idea. Just a second. Just a second. All right. So let's keep on moving and talk about the next idea. Shudhanshu, yes, we will talk about that. Right. So let's focus on the next idea. So here we are. Right. So over here we are Vx is V cos theta, Vy is V sin theta. So we have talked about this idea. So you should look at this thing. A ball is projected upward at a certain angle with the horizontal. Which of the following statement is correct at the highest point? Which of the following statement is correct at the highest point? So based on the discussion we just had, tell me which of the options is true, right? Based on the discussion we just had, tell me which option is true. Okay. A ball is projected upward at a certain angle with the horizontal. Which of the following statement is correct at the highest point? So select the correct point. So you know that at the highest point, which of the following thing is correct? Velocity of the projectile is 0. Is it? We can say that if the body is projected like this, right, at the highest point, the velocity does not become 0. Only the vertical component of the velocity becomes 0, right? So velocity, horizontal component is still there. Acceleration of the projectile is 0. No. Acceleration at every point of the projectile is g. Acceleration due to gravity. So that is not 0 as well. Velocity of the projectile is along the horizontal direction. So yes, at the topmost point, velocity of the projectile is along the horizontal direction. At the topmost point, velocity of the projectile is along the horizontal direction. That is true, right? So ways to best. Beta, I believe your answer is not correct. Srishti, your answer is also not correct, right? And I hope you know right now why is that. Because you see, velocity of the projectile is not 0 at the topmost point. Think about it. If the particle has 0 velocity right now, how will it go? Should it move? If the particle has 0 velocity right now, can I say that it will definitely start falling from there? If the particle has 0 velocity, so it will just fall like this. Yes, yes or no? But at the topmost point, particle doesn't fall like this. It goes further and it travels like this, right? So this journey is only possible when there is a velocity horizontal velocity over there, right? Yes or no? So when a particle is launched, as I said again, the horizontal component horizontal component of the velocity remains unchanged. So even at the topmost point, the horizontal component remains as it is, right? So at the topmost point, all the velocity is in the horizontal direction. Clear? Sudhanshu is saying B. Again, Sudhanshu, acceleration of the projectile is not zero at the topmost point. At the topmost point, acceleration, how can that be zero? Acceleration of the projectile is not zero. Acceleration is everywhere, acceleration due to gravity, right? At every point of the projectile, think about it. If there was no acceleration, how will the velocity increase right now? Because the force of gravity is pulling at every point, right? So there is acceleration to gravity at all points, right? So option C is correct. Now everybody is correct. Now Sudhanshu is correct. And now base to base, that is also correct, right? Okay. So let's move on and talk about the next idea. Okay. So this is the velocity, right? This is the projectile motion, and we have divided the projectile motion into two components, right? V naught cos theta, and after time t, right? So what is this expression? Let me explain you this expression first of all. After time t, you see that velocity after time t in the projectile motion, horizontal velocity will remain as it is, right? Horizontal velocity, the projectile is launched at a velocity u at an angle theta. So it is going to be horizontal velocity Vx is going to be u cos theta, or V naught, you are saying that. So V naught cos theta, right? And Vy is going to be V naught sin theta, all right? V naught cos theta and V naught sin theta. I believe the idea is very, very clear, right? V naught cos theta and V naught sin theta. Is that clear or not? V naught cos theta or V naught sin theta. I believe the idea is very, very clear, right? After time t, what will be the horizontal component? Because as I said, there is no force along the horizontal axis. So horizontal velocity will remain as it is. So Vx after time t will remain Vx cos theta only, right? What will be the component in the vertical direction after time t? What will be the velocity, vertical velocity after time t when the particle is here? So vertical velocity after time t, because the vertical motion is uniformly accelerated motion, so v is equals to u plus ats is ut plus half at square, v square is u square plus 2as, those equations are valid. Vertical motion is uniformly accelerated motion. Acceleration due to gravity is g in the vertical motion, right? So v is equals to u plus at. This is the vertical motion. This is the equation of motion for uniform acceleration, right? So vertical velocity after time t in the vertical direction vy is initial velocity in the y direction uy plus acceleration in the y direction into time, right? So initial velocity in the y direction, my dear kids, is this u naught v naught sin theta, right? Acceleration in the y direction is minus g everywhere, right? And time is t, right? So v naught sin theta minus gt is the vertical velocity after time t. I hope the idea is very, very clear. Yes, Harsh? I believe the idea is very, very clear, right? So horizontal velocity we know, and the vertical velocity we know as well, right? The horizontal velocity we know and the vertical velocity we know as well, right? After time t, right? So once we have covered that, right, we can talk about the next idea, the net velocity after time t. What will be the net velocity? We can say that Vx I cap plus Vy j cap. Yes or no? We have just covered that, right? Vx I cap after time t, the velocity after time t in the x-axis is V naught cos theta. It remains unchanged. And velocity in the y direction after time t is V naught sin theta, right? Minus gt j cap, all right? So this is the net velocity in this particular case. This is the net velocity in this case, right? I hope the idea is very, very clear, right? Okay. Right, we are coming to that, Harsh. We are coming to that. Right, so this is the net velocity. My dear kids, the magnitude of this net velocity we have written over here, right? You see, this is the x component, this is the y component, right? And this is how we are writing the net velocity after time t. This is the magnitude of net velocity after time t. This is how we are writing it, okay? And the direction of net velocity after time t, the direction of net velocity after time t theta is Vy upon Vx, which is this, right? So if a particle is performing projectile motion, for that we have understood the variables, right? Okay. All right. So look at this question, try to solve it. At the top of the trajectory of a projectile, the direction of its velocity and acceleration are. Try to answer it, Harsh. Concept with Abhi. We are discussing the question in just few minutes, right? So because this is the concept plus questions class, not only question marathon class, right? So concepts should be covered as well, right? So look at that. At the top of the trajectory of a projectile, the direction of its velocity and the acceleration are. What is the correct statement? So you can say that at the top of the trajectory of a projectile, the direction of the velocity is horizontal only and acceleration is downward only, right? You see that at the topmost point, velocity is only the horizontal velocity and acceleration is this. This is the horizontal velocity and this is the acceleration. They are perpendicular to each other or not? So option A is correct, right? They are perpendicular to each other, right? Abhi, I believe the idea is very, very clear. Let's keep on moving and talk about the next idea. At the highest point of the projectile motion, right, velocity of the body is 0, horizontal component of the velocity of the body is 0, vertical component of the velocity of the body is 0, acceleration of the body is 0. Which of the statement is correct? At the highest point of the projectile motion, velocity of the body is 0, horizontal component of the velocity of the body is 0, vertical component is 0, acceleration is 0. So we can say that horizontal component is never 0. It is the vertical component of the velocity which is 0. Option C is correct. A body is projected at an angle 60 degree with the horizontal with a speed 20 meter per second. At the highest point, what will be the speed? Answer it. At the highest point, what will be the speed? Very good, Srinivas. Very good, Majabin. Very good, Harsh. Okay. All right. So let's keep on answering it. Okay. Let's keep on answering it. Okay. A body is projected at an angle of 60 degree with the horizontal with a speed of 20. At the highest point, what will be the speed of the projectile? So we can say that at highest point, there is only horizontal speed. Only horizontal speed is there. So which is u cos theta. All right. So you are launching the body at 20 meter per second. So 20 cos 60, right? Okay. So cos 60 is 1 by 2. So it will be 10 meters per second. Okay. Option B has to be the correct option. And let's keep on moving and talk about the next one. Right. Now the next thing is time of flight. Right. This is the first thing that we have to talk about. Right. The time of flight of a projectile. Right. How will you calculate the time of flight of a projectile motion? How will you calculate the time of flight in case of projectile motion? Okay. Let's calculate that. Right. How will you calculate the time of flight? Very good, Srinivas. Right. Very good, Srishti. Right. How will you calculate the time of flight in the case of projectile motion? Let's calculate that. So for time of flight, think about it. Which motion, horizontal motion should be analyzed or vertical motion should be analyzed? Think about it. What is the correct motion which keeps the body in the air? Time of flight is the total time for which it stays in the air, right? Which component of the motion is responsible for keeping the body in the air? Is it the horizontal component? It is responsible for keeping it in the air, or is it the vertical component that is responsible for keeping the body in the air? Which component of the projectile is responsible for keeping the body in the air? So my dear kids, we can say that It is the vertical component which is responsible for keeping the body in the air, right? Vertical component, okay? Right. So let's analyze the vertical motion and calculate the time of flight, right? Let's analyze the vertical motion and calculate the time of flight. Let's analyze the vertical motion and calculate the time of flight. So why are we analyzing the vertical motion? Because the time of flight needs to be calculated, and that is understood by this thing, vertical analysis. So you see that what is happening? Initially, the vertical velocity is v naught. We are launching the body with v naught. So horizontal velocity is v naught cos theta. V naught sin theta is the vertical component, right? So see that what is happening if you are analyzing the motion from A to B. Okay, let me explain you first, right? Okay, imagine we are dividing a projectile into two parts. We are calculating the total time of flight. The total time of flight will be the time taken from here to here. If it is a small t, same time will be taken to come from here to here, t, right? So total time of flight will be 2t. Why am I doing that? But my dear kids, because to analyze it, I need to think about this is launched with the angle theta, this is angle theta, this is v naught cos theta. We don't care about that. We are only caring about vertical component, v naught sin theta, right? V naught sin theta, we vertically component V naught sin theta is something which is very, very important for us now. Now think about it. At this particular moment, if we analyze the motion from here to here, if we analyze the motion from here to here, right, you see that at the topmost point, the velocity in the y direction is 0. In the topmost point, the velocity in the y direction is 0. See, if we analyze the motion from here to here and we use it v equals to u plus at, because in this direction the acceleration is uniform, so we can apply the uniformly accelerated motion, right? Acceleration in the y direction is equals to minus g, right? And everything should be in the y direction, right? Final velocity in the y direction at this point, we are only analyzing from A to B. The time taken is a small t, right? So final velocity is 0. Initial velocity is v naught sin theta minus g into t. So t is equals to v naught sin theta upon g, right? So this is the time the body will take to move from here to the topmost point. Same time will be taken to descend as well. So total time of flight will be 2t, right? So just double that, 2u, 2v naught sin theta upon g. This is the total time of flight. I hope it is making sense, right? Right. So yeah, this is the total time of flight. 2u sin theta. If you are launching the body at an angle at a velocity u, so 2u sin theta upon g will be the total time of flight. 2u sin theta upon g will be the total time of flight, right? Okay. Look at that. The projectile takes 10 seconds to reach the highest point. How long will it take to return to the initial horizontal level from the same highest point? Again, it takes 10 seconds to reach to the highest point. How long it will take to reach back at the horizontal level? So we can say that if the body takes 10 seconds to reach at the topmost point, it will take the same 10 seconds to come back. Option A has to be the correct option, right? Option A has to be the correct option in this case. Right. Look into this question. A football player is throwing a ball with a velocity of 50 meters per second at an angle 30 degrees from the horizontal. The ball remains in the air for how much time? Options are given in second. They are asking about the ball remains in the air for how much time. So basically they are asking about the time of flight. The time for which the object remains, the projectile object remains in the air. The time for which the projectile remains in the air is the time of flight. We have to calculate the time of flight here, right? So we are launching a body at a velocity of 50 meters every second, okay, at an angle 30 degrees from the horizontal, right? The ball remains in the air for how long? The ball remains in the air for how long? What is the total time of flight? So time of flight is 2u sin theta upon g, right? Just apply it, 2u sine theta sine 30 upon g, right? And solve it. That's pretty much everything about this numerical, right? Nothing very serious, simple application of formula and you will get the answer, 5 seconds, whatever. A ball is projected at some angle with the horizontal. It takes 3 seconds to reach the maximum height. What is the time of flight, right? The ball takes 3 seconds to reach the maximum height, 3 seconds. What will be the time of flight? So again, it will take same 3 seconds to come back as well. So time of flight will be 2t, which is 6 seconds. A ball is projected at a certain angle with the horizontal a ball is projected at a certain angle with the horizontal has a time of flight t. If the speed of projection is doubled without changing the angle of projection, what will be the new time of flight? So you see that there are two cases. In the case 1, a ball is projected at an angle theta with the initial velocity u. It has a time of flight t right now. Now in the second case, what we are doing, we are launching the body, right? Now speed of projection is doubled, 2u, without changing the angle of projection. Angle of projection is still theta. So what will be the new time of flight? T dash. All right. So clearly T dash is going to be, let's call the new velocity is u dash, right? So T dash is going to be 2u sine theta upon g, right? Yes or no? T is equals to 2u sine theta upon g. My dear kids, u dash is new velocity is double of previous velocity. So it is double of previous velocity sine theta upon g. We are launching the body at the same angle, right? So we can say that 2u sine theta upon g is the previous time of flight. 2u sine theta upon g is the previous time of flight. So time of flight is simply doubled. Time of flight is simply doubled in this case as well. Yes, Sudhanshu beta. Very good. Yes, Krishna. All right. I hope the idea is very, very clear. Okay. I hope this particular part is clear and we are done with this thing. Okay. This particular part is clear. Okay. Now we can talk about the maximum height of the projectile. So maximum height of the projectile, how will you calculate that? So I'll explain you the maximum height of the projectile, right? Maximum height of the projectile. So which component of the motion is responsible for taking the body to the maximum height? The body is going like this. Which component is responsible for keeping it to the maximum height or taking it to the maximum height? Horizontal component has nothing to do with it. It is taking the body forward. It is the vertical component. It is the vertical component that keeps the body rising upwards, right? It is the vertical component that keeps the body rising upwards, right? Okay. So if I want to know what is H max, right, I can only talk about when I analyze the vertical motion. Yes or no? Right? To get the value of H max, what I need to do? Right? To get the value of H max, I have to talk about the vertical motion. To get the value of H max, I have to talk about the vertical motion. I believe the idea is very, very clear. To get the idea of vertical motion, I have to analyze the maximum height, I have to analyze the vertical motion. Again, you can do that, right? Again, you can do that, right? Let's analyze the motion from A to B. B is the topmost point, right? We are analyzing the motion in the vertical direction. So this is the initial velocity in the vertical direction. The final velocity in the vertical direction is Vy, right? Let's call it Uy and Ux. You are launching it with U, and final velocity is Vy. Clearly, at this point, topmost point, vertical velocity is 0, and we are analyzing the motion from A to B, right? And when you do that, V square is U square plus 2as, you can apply. All the elements have to be in the Y direction. So acceleration is minus G, right? Minus G. Displacement from here to here, displacement is equals to nothing but maximum height H, right? final velocity in the vertical direction is 0, right? And we can put over here, the maximum height is going to be u square sine square theta upon 2g, right? Maximum height for an angle theta is u square sine square theta upon 2g. My dear kids, if you have to answer, if a body is launched at an angle velocity u and I am free to adjust the angle theta, understand one more time. If I am free to adjust the angle theta, then at what angle I must launch the body at a velocity u so that I can attain a maximum height. So of course, to get the maximum height, this component has to be maximum, which is 1, and that can only be 1 when sine theta is sine 90. So if you can launch a body at a velocity u, you have to launch it perpendicularly upward so that you can get the maximum height, right? And this part is clear, I believe. All right. So read the question, try to solve it. Ball P is launched at 30 degree and ball B is 60 degree above the horizontal with the same speed. The ratio of maximum height attained is, what will be the ratio of maximum height attained? Right. The ball P is launched at 30 degree, B is launched at 60 degree. What will be the ratio of maximum height attained? So you know that maximum height attained, right? Because we are launching with the same speed, let's say the same speed of launch is u. So u square sine square theta upon 2g is the maximum height. U square sine square theta is 30 degree upon 2g. This is for the first body. And u square sine square theta 60 upon 2g. This is the second body. This will be cancelled out. This will be cancelled out as well. So h max 1 upon h max 2 is going to be sine square 30 upon sine square 60, sine square 30 upon sine square 60. Sine 30 is 1 upon 2, so it is 1 upon 4. Sine 60 is root 3 by 2, so it is 3 by 4. Right, so this is cancelled out. The ratio is 1 upon 3. Right? So option is option A. Yes, sir. Yes, beta Sona, how are you? 1 upon root 3 or 1 upon 3, Krishna? Check. Check one more time. Have you squared it as well? Right? Because we are taking the square of things. So sine 30 is 1 upon 2, square is 1 by 4. So sine 60 root 3 by 2, so root 3 is squared, root will be removed, so it is 3 by 4. Right? Okay. Bhakti Bhavna is saying Vapis. Okay, no problem. So see what is really happening over here. We have to talk about the ratio of maximum heights in this situation. You are launching the body at 30 and 60. Two bodies are launched at different angles. One is launched at 30, other is launched at 60. So maximum height ratio will be h max 1, h max 2. So this ratio will be there. So u square sine square 30 upon 2g, u square sine square 60 upon 2g. This will be cancelled out. So sine square 30 upon sine square 60. Just put the values and you will have this ratio. 1 upon 3. Nothing very serious about it. Okay, look at this question. Two bodies are projected with the same velocity. Two bodies are projected with the same velocity. If one is projected at an angle 30 degree, other is 60 degree to the horizontal, the ratio of the height attained. This is the same question. The maximum height reached by the ball that is projected with a speed 16 meter per second at an angle 30 degree with the horizontal is the maximum height attained by the ball projected with 16 meter per second. So u square sine square theta upon 2g. So it is projected with 16 sine square theta upon 2g. Let's take g is 10. It is written, take g is 10. Just divide it and you will get your answer. Right? No problem, Krishna. No problem, Krishna. Okay, no problem, beta. I believe the idea is very, very clear. So just divide it and you have the answer. Question is, a ball is projected at an angle 645 with the horizontal with a speed of 20 root 2. Its height from the ground is after 1 second will be. So my dear kids, here you don't have to answer the maximum height of the projectile. You see that? They are not asking the maximum height. They are asking the height from the ground after 1 second. So ball is moving like this and after 1 second, let us say it is here. This is the height after 1 second, t is equals to 1. You have to answer what will be the value of this height. Okay. My dear kids, the formula u square sine square theta upon 2g, that gives you the maximum height of the projectile, h max. It does not give you the height of the projectile at a certain time. You see that t is not there. So this is not going to be applicable over here. Here you have to talk about the height of projectile at a certain time. T is equals to 1. At t is equals to 1, what will be the height of projectile? Right? At t is equals to 1, what will be the height of projectile? This is something we have to answer. Right? So we can easily do that. So to know that, we have to analyze the motion from A to B in the vertical direction, right? Because to calculate height, we have to analyze the vertical direction. You are launching it with 20 root 2 at an angle 45. So you see that you are launching the body at 20 root 2 at an angle 45. So clearly the horizontal component is 20 root 2 cos 45 and the vertical component, initial vertical component is 20 root 2 sin 45. Sin 45 is 1 upon root 2. So initial vertical component is 20 meter per second. Initially vertical component uy is 20 meter per second. And think about it, at point B we have to talk about. We have to talk about the height from the ground after 1 second. So think about it. The body is launched like this. Let me draw it one more time so that it is much clearer to you. The body is launched at a certain velocity. The vertical velocity, initial vertical velocity is 20 meter per second, which is what you have just calculated. After 1 second, the body reaches here, right? So what will be the displacement from here to here? Right? So we can say that S is ut plus half at square. A acceleration in the journey is downward minus g. So you see that displacement is ut plus half at square. You can only apply this equation of motion when the acceleration is uniform. Since the projectile motion is happening near the surface of Earth, acceleration is acceleration due to gravity, and that is common everywhere. Okay. So everything has to be there in the along the y-axis because we are analyzing the y motion, right? Vertical motion. We are analyzing the vertical motion. So displacement in this direction is the height at t is equals to 1. Right, initial velocity in the y direction is 20, time is 1, acceleration is minus 10 and t square is 1 square, right? I hope the idea is very, very clear. All right. So you have 20 minus 5, which is 15 meter. Okay. And that will become your answer. Right? Very good, Sudhanshu. Kanu, Mala, Bharti. Whatever part you want me to explain, Meta, I can explain it again. I believe in the beginning you were not there. I have already explained you most of the concepts, and now we are talking about the numerical problems, right? So numerical problems are fairly easy. So easier problems I have to explain at a faster rate, right? Any problem in this part? You see, knowing is very, very important that what type of motion we should be analyzing. Everywhere the formula will not work. Formula is going to give you the maximum height, but it will not give you the height at t is equals to 1, right? So to know that, you need to know which motion I should be analyzing, because the horizontal motion is uniform motion and the vertical motion is uniformly accelerated motion. Here in the previous page, I have written all the conclusions, right? For those who joined late and those who are joining right now, they can read the conclusions somewhere here. It was way back. I taught you all these things, right? So all the conclusions are written. Vertical motion is uniformly accelerated motion. So whenever you are analyzing the vertical motion to calculate the height at certain time, to calculate the time of flight, right? To deal with those things, you have to talk about the vertical motion. And these equations of motion are perfect for that. To analyze the horizontal motion, we can apply these equations of motion, right? So these are the things we can take care about, right? So let's keep on moving. Time of flight is done, and as well as the maximum height is also done. So the last concept is the range. The last concept is range of projectile. So let's understand that as well. Oh, Pranali, very good. All the best for your test. Pranali Nivane. Which board you guys have? I believe, yeah, hello. Which board you guys have mostly? Can you guys tell me? Which board you guys have mostly? Just a second. All right. Let's continue. Right. So over here, horizontal range of projectile. Now the last concept is about the range of projectile. We have already calculated the time of flight, height of flight, and now the range, right? Now, to understand the idea of range of projectile motion, you can ask yourself which part of the motion, projectile motion, I should be analyzing so that I can calculate the range. Which part of the projectile motion I should be analyzing so that I can calculate the range. Of course, I have to analyze the horizontal motion so that I can calculate the range, right? Okay. And the horizontal motion is uniform motion because there is no acceleration in the along the horizontal axis. There is no acceleration along the horizontal axis, right? So you see that the body has an initial velocity u. So along the horizontal axis, the component is going to be u cos theta. The total time for which the body stays up in the air is capital T. So the range is going to be ux into the total time of flight. So this is something I have explained you while explaining the braking of projectile motion in the beginning of the second part. Right. So here it is. Horizontal component, initial horizontal component is u cos theta and time of flight is t, which is 2u sin theta upon g. So cos theta and sin theta, 2 sin theta cos theta is sin 2 theta. So range is going to be v square sin 2 theta upon g. Range is going to be v square sin 2 theta upon g, right? Okay. So let's continue. Range of the projectile, done. All right. Range of the projectile is done. Okay. Now, to get the maximum range, at what angle you should be launching the body? For maximum range, let's say that I can throw the body at a velocity u and angle I can adjust. So at what angle I must throw so that I can get the maximum range? My dear kids, over here you can see that, for the range to be maximum, sine 90 should be there, theta should be 45 for sine theta to be sine 90 over here, right? Because there is 2 theta. So when theta is 45, 2 theta will be sine 90 and range will be maximum, right? So maximum range is going to be v square u square by g, and this will be achieved when theta is equals to 45. So yeah, when you're launching the body at a 45 angle, so you will be getting the maximum range for sure, right? Okay, right. Look at that. What is the range of a projectile when you are launching at 10 meter per second and angle is 15 degree, right? So clearly you can say that angle range of the projectile is over here we have seen range of the projectile is u square sin 2 theta upon g. So range of the projectile is u square sin 2 theta upon g. So you are launching the body at a velocity of 10 meter per second, my dear kids. Sin 2 theta is going to be sin 2 into 15 is sin 30 upon g. So it is 10 sin 30. Sin 30 is 1 upon 2. So it is going to be 5. Okay. So the answer is going to be 5 meters. That will be the range of projectile motion in this situation. Now, you see that for angle theta and 90 minus theta, right, you get this expression, for angle theta and 90 minus theta. The range will be same in both the cases, because if you put theta in place of theta, you put 90 minus theta. So 2 will be multiplied inside. So it will become 180 minus 2 theta, and sine 180 minus 2 theta is again sine 2 theta. So you see that the range for angle theta and 90 minus theta is same. These two angles are called as complementary angles, right? The range for theta and 90 minus theta is same. So if you are launching a body at an angle 30 degree and 90 minus 30 means 60 degree. So you're launching at 30 degree, it is moving like this. You're launching at 60 degree, it is going to move like this, right? At the same velocity, they will cover the same, wait. All right. Right. Okay. So let me show you in the diagram first, right? You see that you're launching the body at 30 degree and you're launching the body at 60 degree, theta and 90 minus theta. You see that here it is following this path, and at 60 degree it is following this path, right? Let me try to draw it like this path and this path, right? You see that the initial and final points are same. This angle, these two angles, theta and 90 minus theta, are called as complementary angles. So 30 and 60 are the complementary angles. For them, you are getting the same range. Similarly, 15 degree, you are launching here, ending here, and at 90 minus 15 is 75. So the body will go like this and over here. So these two angles are again complementary angles, right? Look into this question. A ball is thrown from a point with a speed v0 at an elevation angle of theta. From the same point and at the same instant, a person starts running with a constant speed v0 by 2 to catch the ball. Will the person be able to catch the ball? If yes, what should be the angle of projection? Think about it. Okay. Try to think about it. Okay. So question is, a ball is thrown from a point with a speed v0 at an elevation angle theta, right? A ball is thrown from a point at a speed v0, right? Thrown from a point with a speed v0 at an elevation angle theta, right? From the same point at the same instant, a person starts running with the constant speed v0 by 2. So person is running at the same instant, at the same point, at the speed v0 by 2, right? So the person will not be running at an angle, person has to run along in this direction, right? So the question is, what will the person be able to catch the ball? If yes, what should be the angle of projection? So you see that the ball is thrown, right, and the person starts running. So in order to catch the ball, at what angle I must launch the ball at the first place, right? Think about it. Think about this question for a certain time. Rupali, question is clear? Seema, I believe the idea is very, very clear. These particular formulas that you have written, they are only valid for specific cases. If you have to, like I have given you the question where you have to talk about the height of projectile after 1 second. So in that case, you have to analyze the vertical motion. That is the best approach. So here, the body is launched at an angle theta. How fast this person should run so that this person catches the ball ultimately, right? Think about it. Think about just think about the logic. Okay, just think about the logic. If the ball has horizontal component, right? If the person wants to catch the ball, right? The horizontal component of the ball is moving like this, right? If the person wants to catch the ball, the horizontal component person must match the horizontal component of the ball, right? If the ball has a faster horizontal component, so think about it, ball is covering more distance in this direction per unit time than the person is covering. So after 10 seconds, the ball will be further away and the person is going to be here, right? We can say that when the person and the ball have same horizontal component, in that situation only, the person will be just beneath the ball. And when the ball is reaching over here at his level, he can catch it, right? So my dear kids, the person must match the horizontal velocity v naught cos theta for the ball so that he can catch it, right? Person must match the horizontal component of the velocity so that he can catch it, right? So to do that, v naught by 2 velocity of the person must be the horizontal equals to the velocity of the person must be equals to the horizontal component of the velocity v naught cos theta, right? That must be true. Yes or no? So v naught will be cancelled out and theta will be 60 degree, right? So he can catch the ball if you are launching it at a 60 degree angle, because when you are launching at 60 degree angle, what will happen? Yes, Seema, very good. Rupali, clear? The question is very clear, right? If you are launching a ball at an angle theta, right, the ball will definitely move ahead, and the ball has two components, horizontal and vertical. Because of the horizontal component, the ball wants to run like this, right? And because of the vertical component, ball wants to move up. My dear kids, if the person can catch the ball or not depends on if the person is with the ball or not. If the ball is moving further and the person is over here only, he will never be able to catch it, right? We want the person to be just under the ball so that when the ball reaches at his height, he can catch it. He is just under the ball and he can catch it. For that to happen, the horizontal velocity of both the elements must be same so that they can meet. So horizontal velocity of the ball is v naught cos theta. That must be equals to the person's velocity v naught by 2. And that is only possible when you are launching the ball at an angle 60 degree, right? Okay. I hope the idea is very, very clear. Got it? Sudhanshu, clear? Very good. Yes, better here. All right. So let's keep on moving and talk about the next idea. Look at this question. Balls A and B are projected at different angles above the horizontal with the same velocity and has the same range. There are two balls, ball A and ball B. They are projected at different angles above the horizontal with the same velocity and they have the same range, right? The ball A and B are projected at different angles above the horizontal with the same velocity and have the same range. If the angle of projection of A is 25, what will be the angle of projection of B? So I don't need to draw this thing because they have the exact same range, right? And they are launched with this, with the same velocity. Since they are launched with the same initial velocity, right? And they have the exact same range. That is only possible when they are launched at complementary angles, right? When you are launching one ball at an angle 25, right, and you are launching another ball at 90 minus 25, which is how much? 65, right? No, 55. Sorry, पहले सही था. 65 degree, right? It is 90. I thought it is 80. Now it is good. So you are launching a body at 25 degree and another one at 65 degree. So this is launched at 65 degree, this angle, right? And the other one is launched at only 25 degree. So these bodies are going to have the exact same range. So theta and 90 minus theta, they are called as complementary angles. So one is 25, 90 minus theta is 65. So clearly option C is the clear option. Right? Very good, Sudhanshu. Ria, what is happening? I believe the idea is very, very clear. Right? Question is saying the maximum range of a gun on horizontal terrain is 16. What will be the muzzle velocity of the shell? The maximum range, you see that they are giving you the maximum range of a gun, right, on a horizontal plane is 16, right? So at what range you might be launching the gun? Think about it. If you launch the gun straight, the bullet will definitely start feeling the weight and drop like this, right? You will not be getting the maximum range when you draw, fire like this, right? But on the other hand, when you launch the bullet at an angle, right? So they must be at an angle at which you are launching the bullet so that it can cover the maximum range, right? Okay, what angle that might be? 45 degree, we know that, right? So what should be the muzzle velocity? Muzzle velocity means velocity at which it is leaving the muzzle, right? So velocity is, let's say, is u, right? Okay. So what is that? So here we have seen it. For the range, it is very clear. For the range, it is very clear that range is u squared sine 2 theta upon g. Here u is going to be the muzzle velocity, right? Range is u squared sine 2 theta upon g. So u is the muzzle velocity over here, right? U square sine 2 theta upon g. My dear kids, here we are getting the maximum range. So clearly the theta should be 45 degree and sine theta must be 1, right? So range is maximum, which is u square by g, right? So which is given in the question 16 kilometers. So that many meters, u square is the muzzle velocity upon g. G is 10. So 10 will go on the side because so u square will become 16 into 10 to the power 4. So u will be 4 into 10 to the power 2 or 400 meters per second, right? So you have to launch the body. The muzzle velocity is going to be 400 meter per second. The acceleration of the projectile at the highest point, not just at the highest point, at every other point, right? The acceleration at the topmost point, not just at the topmost point, but every other point in the projectile journey is minus g, right? Okay. All right. All right, my dear kids, let's keep on moving and talk about the next idea. Okay. A shell is fired from the ground for the maximum horizontal range with an initial velocity 20, right? Initial velocity is 20. The value of g is taken as 10 meter per second square. The maximum horizontal range, my dear kids, maximum horizontal range is obtained when the angle of launch is 45, and here you have seen it. The maximum horizontal range is u square upon g. So it is u square upon g, right? So u square is 20 square, it is 400, and g is 10. So it is going to be 40 meters. Option B is the correct option, right? Okay. All right. Now, the next article we need to understand. This article has now been completed, and the next article that we have to understand is called equation of path of projectile, right? Equation of path of projectile. My dear kids, many of you might be math students, and those who are math students should know that every path has a certain equation, right? For example, if a particle is having a separate particular center and that particle is performing the circular motion about the center, so you see that this is the center is taken as origin. So in that situation, if this is A, right, every single moment the value of x and y is changing, right? Okay. You see that every single moment here the value of x and y is different, here the x and y is different, at every single point the value of x and y is different, but at every single moment the x and y values are related, right? With the formula x square plus y square is equals to a square, you call it the equation of circle. So if a particle is moving on a certain path, right, the x and y coordinates are going to be related by a certain equation, because that equation will give you the equation of that path. If the projectile motion is happening, right, so x and y coordinates are changing as well. If this is taken as the origin, right, this is origin, initial point. So here we have x1, y1, x2, y2, x3, y3, x4, y4 and so on. So xy coordinates are changing. So with the time, x and y coordinates will change, but they are always related to each other, right? X and y coordinates are going to be changing. So after time t, what will be the relation between x and y location of the particle which is performing projectile motion? That will be the equation of projectile, right? Equation of projectile can also give us one very interesting insight about the path of projectile as well. Let's have a look at that. The body is launched at an angle theta, right, performing a projectile motion with the initial velocity v naught. So the horizontal component is u cos theta, vertical component is u naught sin theta, right? Okay, these are the two components. We want to know the equation of projectile. So what we have done, we are analyzing the horizontal motion first. So we don't need to do that, because in the horizontal motion, the acceleration is 0. So simply we can say that displacement is velocity into time. But we are writing it, no worries. The second part of the thing is already getting 0. So no worries about that. So displacement is velocity into time. Velocity is how much? Velocity is v naught cos theta into t, right, plus 0. So this is the displacement at time t, right? So displacement along x-axis after time t is v naught cos theta into t. Similarly, what will be the displacement along y-axis after time t? Apply the equation in the y-axis, sy equals to u by t plus half v by t square. So everything has to be in the y direction. So displacement in the y direction, vertical velocity component is v sin theta, your u naught sin theta, and ay is minus g. So this is the displacement in the y direction after time t. Displacement after time t in the x direction. Displacement in the y direction after time t, right? So you know that x and y coordinate. X coordinate after time t is this, y coordinate after time t is this, right? Okay, clear. Now you see that we can eliminate the time, because we want to know the equation of path. We want to know the equation of path. We can get the value of time from here. Time will be x upon v naught cos theta, and put it over here. So x upon v naught cos theta, x upon v naught cos theta square. So we will get this, right? So think about it. In place of t, we can put t is equals to x upon v naught cos theta. So y will be v naught sin theta into x upon v naught cos theta minus half g t square x upon v naught cos theta. We want to know the equation of projectile. So we want to know the equation of path, right? So v naught is cancelling out. So it is going to be x tan theta minus, right, so minus gx square upon v naught square cos square theta, right? I hope the idea is very, very clear. So this is the equation of parabola, right? Y is equals to ax plus bx square. This is the equation of projectile parabola, right? Y is equals to ax plus bx square. This is the equation of projectile motion parabola, and minus means it is downward parabola, right? The equation is coming out, y is equals to ax minus this whole thing is bx square, right? So for this parabola, the direction is, it is a parabolic equation, y is equals to ax minus bx square. And since there is a minus sign over here, it is a downward facing parabola over here. Look at that problem. A particle is projected with speed u at an angle theta, at an angle alpha with the horizontal. The path will be upper parabola, lower parabola, right? Because you are launching at an angle theta, it will be a lower parabola here, of course, right? The trajectory of the projectile is given like this, where x and y are in meter. The range of the projectile is going to be. So what will be the range of projectile? Right. Think about it. What will be the range of projectile? Okay. What will be the range of projectile? Seema Yadav. Beta, for circular motion, we are going to have another lecture. Right. Circular motion will not be covered in this lecture. Right. Okay. I believe the idea is very, very clear. Right. Okay, okay, all right. So you see that this is the equation of projectile they are giving us when the particle is moving. X and y coordinate of the projectile are related by this particular equation for that particular projectile, right? So we have to talk about the range of projectile in this situation, right? You look at that, y is equals to x upon root 3 minus gx square upon 20. X upon root 3 upon minus gx square upon 20. So my dear kids, we can definitely go ahead and talk about this idea. Look at that, the equation of projectile is x tan theta minus gx square upon 2u square cos square theta, right? X tan theta minus gx square upon u square cos square theta. Yes or no? Right, focus over here, 2u square cos square theta, sorry. Right, this is the equation of projectile. Okay, so when you compare it, compare the motion of equation of given projectile with the standard equation, you can simply say that in place of tan theta, I have 1 upon root 3. Yes or no? Right, gx square, and in place of this, I have this 2u square cos square theta is 20. Yes or no? When I compare it, Seema, Seema Yadav. So I have explained this idea in the beginning of the class, right? What is displacement vector, velocity vector and all, right? So you have to watch the recording of this particular class, right? No problem. All of this is already covered, right? Okay. Let's continue, my dear kids, right? So by comparison, we can say that tan theta is 1 upon root 3, right? Tan theta is 1 upon root 3, okay? And by comparison, we can say that 2u square cos square theta is going to be 20, right? So these two things we can get from here. We need to know the range of the projectile. We need to know the range of the projectile, right? Okay. So range of the projectile, my dear kids, is u square sine 2 theta upon g, right? Range of the projectile is u square sine 2 theta upon g. First of all, tan theta is 1 upon root 3. So what should be the value of theta over here, right? Tan theta is 1 upon 3. So tan theta is tan 30. So clearly theta is going to be 30 degree, right? Tan theta is 1 upon 3. So theta is nothing but 30 degree. Okay. This is 2u square cos square theta. So put 30 degree over here. 2 is cancelling out, it is 10. Okay. So it is u square cos square 30 degree. Cos 30 is root 3 by 2. Square it. We have to say cos 30 is root 3 by 2. Square it. So it is 3 by 4. That is 10. Right. So u square is 40 by 3. So u is equals to, u square is 40 by 3. That is useful for us. Right. Because directly we will have to put u square over here. So no need to get the under root and all. So u square is 40 by 3. The value of g you can take as 10. And sine 2 theta is sine 60 degree, which is root 3 by 2. Two upon root 3. Right. 2 upon root 3 is the option B. Right. 2 upon root 3 is the option B. Okay. And option B is the correct option over here. Right. Okay. All right. Good evening, beta. Okay. I believe all the ideas are absolutely clear till now. Right. You need to watch, Seema, I will suggest you to watch the recording of this class one more time so that the basic concepts that I have already taught are already clear with you. Okay. All right. Look at one more question, my dear kids. An object is projected with a velocity of 20 meter per second. It is making an angle of 45 degree with the horizontal. The equation of the trajectory is h equals to ax minus bx square, where is height, x is total horizontal distance, a and b are constant. What will be the ratio of a upon b? What will be the ratio of a upon b? You see that the height of the projectile at a certain time t is written as ax minus bx square, right? So my dear kids, this particular projectile, right, here we have to relate the height of the projectile with x, right? Here we have to relate the height of the projectile with how far it is, this height of the projectile with how far it is. Basically we are relating y with x, right? Height of the projectile at a certain time is written as h, but h doesn't give us that intuition. So we can imagine it is y and it is x. So here we have to relate the h and a, right? So h and x, right? So a and b, the ratio of a upon b you have to talk about. My dear kids, this is the equation of projectile. But the real equation of projectile, you know, right? This is the given equation. The real equation is y is equals to, you see that here, x tan theta minus, right? You see that gx square upon 2u square cos square theta. All right. I hope the idea is very, very clear. So you see that a, in place of a we will have tan theta, and in place of b we have all this expression. So the a upon b, what will the value of a upon b, my dear kids? A is tan theta and b is this. So g upon this will go up, right? Okay. So we can solve it. So this is 2u square. Tan theta is sin theta upon cos theta, right? This g I am writing as it is over here, and cos square theta is over here. So cos square theta, this and this can be cancelled out. So this is 2u square upon g sin theta cos theta, right? So 2 can be written with this. So it is u square 2 sin theta cos theta is sin 2 theta upon g. U square sin 2 theta upon g, right? So what is this? A upon b, right? What is this? A upon b? We can say that it is written over here, right? So the value of u is given in the question, 20 meter per second. So 20 square is 400. Sine 2 theta is sine 2 into 45, which is sine 90. Sine 90 is 1. So 400 into 1 upon 10, which is 400 upon 10. So answer will be 40, right? So you can put the values if you want to. 400 into sine 2 into 45 upon 10. So answer will be 40 meter per second, right? So A upon B is 40. The ratio of A upon B is not 40 meter per second because it's a ratio. So it is just going to be a number, right? A upon B is going to be 40:1. So option D has to be the correct option, right? Rupali? Okay, I will explain you one more time. Right. So my dear kids, how will you solve this particular question? It is very, very clear that if you have this particular equation, if you have this equation of a given projectile, Rupali beta, right, it is this, h is ax minus bx square, right? So what is really happening? Y is x tan theta minus gx square upon 2u square cos. This is the standard equation, right? So we are doing is we are comparing the coefficient of x is a, the coefficient of x is tan theta. So here a is tan theta. We have written it. Coefficient of b is x square is b. Coefficient of x square is this. So this is b over here. A upon b can be written as tan theta upon this whole thing. So g and this thing will go up in the numerator, right? So we have further solved it and we got this expression. We put the value and we got the answer 40, right? So 40:1 is the answer. Rita. Okay. So just for those kids who are joining right now, they might find it slightly difficult because now the numericals have improved so much. I have also given you simpler numericals after the explanation that will just enable you to understand the formula in a better way. And my dear kids, this is my complete faith in you. Like if you watch the recording, you will definitely get through even these numericals as well, right? They are not very tough numericals for this chapter. There are better numericals than this one as well. But the idea of this lecture is to give you the basic understanding, the conceptual understanding of all the concepts, right, in less than 3 hours. Look at this question and try to solve it. The equation of projectile is ax minus bx square. The horizontal range is y is ax minus bx square. Its horizontal range is, so what will be the horizontal range? Think about it. Right. My dear kids, if in the previous numerical you have seen, in the equation of projectile, the coefficient of x is a, the coefficient of x square is b. If I try to find a upon b, I get this expression u square sine 2 theta upon g. What is this? A upon b is u square sine 2 theta upon g, right? If I write the equation of projectile, if I write the equation of projectile and I call this particular part as a, if I call this particular part as a, and if I call the coefficient of x square as b, right? If I call this particular part as b, okay? So this is a and this is b. So the equation is y is equals to ax minus bx square, right? So this is a, this is b. So when I try to get the ratio of a upon b, what did I get? When I try to get the ratio of a upon b, so you see that a is tan theta beta and b is g upon 2u square cos square theta. So this will go up g upon 2u square cos square theta, right? So tan theta upon g, and this will go up 2u square cos square theta. What will you get? Tan theta is sin theta upon cos theta. This is 1 upon g, right? So it is 2u square cos square theta, right? So you see that this is cancelling out. So we have 2u square you can write in front, sin theta cos theta upon g. So we have u square, 2 sin theta cos theta is sin 2 theta upon g. U square sin 2 theta upon g. What is this? My dear kids, what is this? U square sin 2 theta upon g. What is this expression? U square sin 2 theta upon g, my dear kids. Amit. What is u square sin 2 theta upon g? We can say that u square sin 2 theta upon g is nothing but the range. So a upon b is nothing but the range, right? So in the equation of projectile motion, the coefficient of x is a, coefficient of x square is b. So a upon b is the range of the projectile motion. A upon b is the range of the projectile motion, right? I hope the idea is very, very clear. Now look at this question and try to solve it. Now look at this question and try to solve it. The equation of projectile is y is ax minus bx square. The horizontal range is, what will be the horizontal range? See, Seema, in the projectile motion, I have explained some topics about the projectile motion, right? Around what time? Let me tell you. So if you watch the recording, let me tell you the exact time duration. Here I am reading your chats as well. Yeah. All right. You got the concept? No, beta, you didn't get the concept at all, right? So around, if you just go back, it shows the time with a negative sign. So minus 1 hour 40 minutes. Around that mark, you have to watch the replay of that part, right? So the equation of the projectile is this. What will be the horizontal range? My dear kids, the equation of the projectile, we know that the coefficient of x is a, the coefficient of x square is b, then a upon b actually tells us the range of projectile, right? Coefficient of x is a, coefficient of x square is b, so a upon b actually tells us the range of projectile, right? Okay. All right. All right. So this is the recap part, my dear kids. Quickly recap. So here we can say that the projectile motion is defined as the motion when the object is projected into the air at an angle theta less than 90 degree. Here the time of flight of the projectile is going to be 2u sin theta upon g. The range of the projectile is going to be u square sin 2 theta upon g. And the height of the projectile is going to be u square sin square theta upon 2g, right? Equation of the projectile over here, you can say that it's x tan theta minus g square upon 2u square cos square theta. These are all the basic formulas, and we have also solved really interesting problems on the basic concepts, right? Okay. So I believe that was pretty much everything about this class, right? And we have covered the key and interesting ideas about this particular lecture, right? So this is the summary of what we have done so far. My dear kids, we were talking about motion in a plane, right? Motion in a plane. So my dear kids, first of all, in the part 1, So in the part 1, so in the part 1, what did we discuss? Right. So in the part 1, we discussed the terms of motion in a plane. Terms of motion in a plane. So what are the terms? The first term we talked about is displacement vector. Right. Also, we discussed the numerical problems on it. Right. After the displacement, we talked about the velocity in 2 dimension, and also with the numerical problems. After this, we discussed the acceleration in 2 dimension, and again with the numerical problems, right? So these are the terms we have understood. After these things, after talking about the terms of motion in a plane, we discussed another concept. What was another concept? After discussing the terms of motion in a plane, we discussed the idea of projectile motion. So the first thing that we have understood in, let's say, in around 30 minutes, I have explained the what's happening inside the projectile motion. So we try to understand and we break the projectile motion, breaking the projectile motion. This is the most important part. After that, we talked about how to analyze the horizontal and vertical component and calculate the time of flight, the height of projectile, maximum height of projectile, range of projectile, and equation of motion of projectile. Right? So these are the things we have discussed in this particular lecture, right? These are the things we have discussed in this particular lecture, right? Okay. All right. All right. So my dear kids, let's keep this class till here only. I hope you have understood all the concepts in an extremely detailed way, right? There is a still lot to understand in this chapter, but that's that for in the given time duration. These are the topics we understood in a very meaningful way, right? So let's keep this class till here only, and I will see you there in the next class. Till then, take care, my dear kids. Bye bye.